Okay, and we are live. Please let me know how it sounds in the chat. Please hit the like button. Um, Comment in the chat how everything sounds, how everything looks. Like I said, this is all pretty new. It's a totally new studio, even though it looks exactly the same to you guys. It's not. And I'm still getting some of the kinks worked out. So uh, here we go. Let me see this. All right, looks like we're good. But I think it's going to be a good stream tonight. Um, I feel like I say this pretty often, but I'm going to say it for just, I guess, tradition's sake at this point. We will get on a more consistent schedule. But if you were not aware, I recently moved to a new state and I ended into a new house, and I have been setting up a new house, and it was moving is a huge chore. So we took a bit of a break and we came back. This is the second stream back. I'm definitely looking forward to getting back on a different schedule. I'm in a new time zone too, which should eventually help us start earlier, but it is also difficult to get adjusted to a new time zone. But yeah, so we're going to talk tonight about a really good discussion that was the first talk on Curt Jaimungal's Theories of Everything YouTube channel. That is the part. It is the first episode of the Rethinking the Foundations series that he has started. So I think that's a great name for a series that's very needed in physics right now. And we're going to talk about that tonight because basically we're going to discuss what it means to start physics from scratch and start rethinking cosmology from scratch and the context of our sciences and our even society and our personal responsibilities and meaning, and it's all connected, and that's such a trope. Oh, it's all connected. Watched a show with my wife. Forgot what it was called, but the whole thing everybody said all the time was it's all connected. It's people go, I don't know, a plane goes missing for they disappear for 5 years or something. I forgot the name of the show, but it's not bad. But it really is. It's not just a cliche. It is actually deeply, intrinsically, inevitably true to the point where it really does need to be acknowledged. To dismiss it is to dismiss reality and to head down a fruitless and incorrect path, I believe, in terms of making sense of everything. So, but we're going to talk about this talk. It's a pretty informal talk that they did. I think he's done another talk with Curt before this, and I listened to some of it, and I just remember it being very good. I had never heard of Neil Turok. I hope I'm saying that correctly. Before seeing him on Curt's stream, and he's a very interesting academic thinker because he is just one of those people that is willing to, I think, have the humility to question himself and the environment that he is within, which is academia. So let's do background on him. Neil Turok, sorry. I apologize. I'm sure one of those is wrong, at least. He holds the Carlo Fidani Roger Penrose Distinguished Visiting Research Chair in Theoretical Physics at the Perimeter Institute. And his research focuses on developing fundamental theories of cosmology and new observational tests. His predictions for the correlations of the polarization and temperature of the cosmic background radiation and of the galaxy CBR correlations induced by the dark energy have been confirmed in detail. Okay. See what else is maybe worth mentioning here, but you can look up his background online. He's a theoretical physicist, and I would say someone who's quite atypical for being involved in academia, and that's because the primary theory that is assumed to be the dominant and probably correct, if you asked, I don't know if that's the right word that they would use, but it's the dominant theory in theoretical physics right now is string theory, and seems to state some very, I think, obvious and important things about the state of string theory. And there's other people that have mentioned it as well, but I think he gets into some of the specifics that are important. So, yeah, without further ado, please, like I said, hit the like button, and we will get started. And like I said last stream, I'm a little rusty at this. It's, I took a month break. That doesn't have no effect. So the stream that we're going to be discussing, by the way, is linked below. If you want to watch the entire stream on Curt's channel, I would highly recommend always doing that. I always link the streams that we discuss in the description below, and I always recommend watching the entire discussions. But let's go to the first clip. We're going to discuss how this relates to my work on sentient singularity theory, and kind of just how it impacts the state of science going forward, and not just physics, but science, even political science, like a hardening of political science, a hardening of social science. They would no longer be soft sciences. If you go down the specific road, that is the inevitability, is that there's no such thing as a soft science versus a hard science. That is a totally artificial label that has been created to basically appeal to people's, I guess, opinions, because there's, political science has a lot of quote unquote opinions, but there's also a lot of truths that are, fundamental, that are probably not discussed by any side in politics fairly regularly. And, we'll get into that later on, but let's get the first clip. Okay. So I loved this. He was asked by Curt about the multiverse, and we've talked about the multiverse on here before, and I think he gets a good point in about it. So,
what is your gripe?
Let's see. Like I said, I'm rusty.
Concept. And also, what do you make? What your gripe with the multiverse concept? And also, what do you make of the concept of a wave function of the universe?
Great questions. The multiverse, to be honest, I'm a fairly open-minded person. I'm not dogmatic about anything. I think science is precisely about discovering what's true, and the worst thing you can do is bring too many preconceptions. As I said, my fundamental belief is that the universe teaches us things. We need to be willing to learn, and you don't learn if you come to something with a fixed idea. You don't learn. So I am open-minded. I wrote a paper with Stephen Hawking, essentially about the multiverse. Stephen liked the multiverse idea, but
why?
Yeah, it's hard to ask him why. I never really took to it, but as I say, I was sort of open-minded. And it looked like, I was willing to explore string theory for as long as it looked like it was leading us in an interesting direction. And string theory sort of indicated something like a multiverse. And so I thought, okay, well, let's try it out, But my problem was that I am only interested in theoretical physics to the extent that it describes nature. Okay, that's the only reason I'm interested in it. I'm not interested in it as a mathematical exercise. What I am interested in is this extraordinary fact that human beings, who after all are, essentially monkeys who have evolved out of bacteria in the primordial ooze. Somehow, through some means or other, we don't yet understand, we develop the capacity to understand the whole universe. It is just completely insane. And I find that so profound and so wonderful that I'm very happy to devote my life to try to, you know, explore this fact about the universe, that we have the capacity to understand it. It's amazing and it's bizarre. So if you like, I view my work as homage to this fact.
Okay.
That for some reason human beings have the capacity, and I shouldn't say human beings opposed to animals. I think animals and humans essentially learn in very similar ways, and we all have this ability to learn about the world. So I don't want to separate humans from any other form of life.
Sure.
I rather liked your what was his name? Bernard Kastrup, his view.
Oh, Bernardo Castro.
Yeah, I rather like that point of view, that, you know, we are consciousness and we're all individual aspects of that. As a philosophical view, I kind of like that. So I'm not a materialist.
Interesting. Is that common in your colleagues?
No, but I believe in exploring, you know, and that's what motivates me. When string theory started to make excuses, and I view the multiverse as the biggest excuse of all time, you know, okay, we can't predict this universe, but we can predict a billion others, you know, I began to lose confidence. And I lost confidence because you're no longer predicting anything. And if you can't predict anything, you can't really check your ideas. You know, you may be just engaging in a fantasy. That's a terrible danger. If you're a theorist, the danger that you're just deluding yourself is enormous, right?
Okay, so he speaks like I do. He branches off a lot, and so but I mean, it's good. It's good stuff, and it's funny because I've asked people, and I'm doing it right now. But I've asked people who are on our Discord community, which if you'd like to join, we have weekly calls every week. Send me a private message on Instagram. But I've asked for some help, and also some of them have volunteered to pick clips out from the streams, and it's become difficult because I branch out so often and I don't keep a single train of thought. But whatever. I guess some people seem to like it, but so what he's talking about though with the multiverse is very funny when he's like, I am only interested in theoretical physics insofar as it is an attempt to understand the natural world, the real world. And that is something that physics has completely lost. We're going to talk about it in regards to Sean Carroll in a bit, because I'm going to give an example of him. I know he's going on Curt's channel soon. I'm very much looking forward to that, to watching that. But so the multiverse, and then he goes on and he says, we can't predict why this universe is the way that it is, but we can predict a billion other universes, not even a billion, infinitely more other universes. And that somehow allows for us to ignore the fact that we can't predict this universe. And that is what the multiverse is. It is the ultimate excuse, as he puts it. And it's more than what he's saying, but it is definitely also what he is saying, and very importantly, what he's saying is very important in understanding what it is, this idea, the multiverse, and also why it is, and why it is a problem. It's a fruitless idea. It's not that there aren't multiple universes. If you even in Sentient Singularity Theory, a universe, quote unquote, or what I call cosmological verse, births another cosmological verse within itself, and then that one births another one within itself. And so there is a chain of multiple verses, or of nested there is a nested chain of multiverse chain. There's a nested multiverse chain in Sentient Singularity Theory, but there's a context to it, and it emerges from the pursuit of constructing a logically coherent framework of cognition and perception. It's not an afterthought insert to basically be a band-aid or distraction from another problem, which is what the multiverse in mainstream physics is. It is a distraction from the fact that we can't actually solve this other problem, and then it is used as an answer to this question that we can't actually solve, which is why is this universe here, and why is it the way that it is? And it's more than that. More than that, it is an attempt to sidestep God. What I mean by that is it is an attempt to not require a creator in your metaphysical framework. That is what it is. And it actually doesn't successfully do this. And it also doesn't successfully explain why our universe is here and why it is the way that it is. So it literally is fruitless and completely. And it's just a distraction in the context or the lack of context that it is presented in mainstream academic physics. Yes. By the way, I'm getting a message saying that it is the video. It might not be best quality. Let me know in the chat if it all looks good or not. But hopefully. But that's what it is. It's both of those things. It's the ultimate excuse for why we can't do anything, why we can't predict anything, and it's also the ultimate snub to God. And I'm going to show exactly why this is the case. And we'll talk more about this also. I'm sure we're going to talk about Curt's talk with Sean Carroll, probably. I can't imagine that I wouldn't want to talk about that stream. But EveryOne. Okay. If you go to my channel and you click on here, you will see, go all the way back. Here.
If you did believe that God was a necessary being, that you literally could not imagine a universe in which God did not play an important role, in order logically for me to refute that belief, all I need to do is to invent a universe in which God does not exist.
Invent a universe in which God does not exist.
So according to Sean Carroll, all we have to do in order to show that a conscious creator is not necessary to the existence of a universe is consciously create a universe. Does anybody else see the problem with this? Taking it way back, guys, that was literally 4 years ago. That's wild that we've been doing this for 4 years. But so Sean Carroll is a proponent of the multiverse theory as well, and he talks about it in that talk that I was referencing in that video. You can watch more of it, and it's basically, it is when people present the I mean, it's an attempt to sidestep multiple problems at once, and it doesn't actually sidestep any of them. It doesn't answer any questions. It just distracts you and kind of tricks you into thinking that you've answered the question. So if you and Neil very precisely and coherently got to that point where he said, we can't explain this universe, why it is the way that it is and why it is even here. So we're going to predict a billion plus other universes, and because now there's so many of them, one of them has to be like the one that we're in, and therefore we're in the one that is the way that is our universe. And so that's the answer as to why the universe is here and why the universe is the way that it is. That doesn't actually get neither one of those two questions. Why is the universe the way that it is, and why does the universe exist? Why is the universe, you could say. But neither one of those questions is answered by the multiverse concept. And also the idea that there's infinitely many universes out there, and they all are different, and they're all random, and so there's no need for God, because there inevitably will be a universe with every possible set of rules that could exist, and that the multiverse idea does not actually successfully sidestep God either. And you can see that when Sean Carroll tried to explain, why he could sidestep God and say, oh, well, or creator, and say, oh, yeah, well, in order for me to, disprove the idea that a conscious creator is necessary for the existence of the universe, all I need to do is create a universe in which God does not exist. He doesn't even think about the fact that he just did something, he just failed to do what he was trying to do, and that there's no logical way to do what he was trying to do, because he is God in this example. He's creating the universe. He is God. He is the conscious creator that is necessary. And what's interesting is that Neil also mentions this as well. And he said, later on in the stream, he basically says that a creator might philosophically be required. Essentially, this is it. This is the clip.
But you see a universe like ours, whereas our mirror hypothesis does. Our mirror hypothesis predicts a flat, spatially flat universe, homogeneous and isotropic, which looks like ours. So I would say it's just an alternative to Hawking. Just like Hawking, we have no extra inputs. You see, what I think doesn't really make sense philosophically, or at least I shouldn't say philosophically, maybe it does make sense philosophically to have a creator, but what is not very appealing, let's put it that way, scientifically, if I want a predictive theory, I do not want the freedom to input stuff at the Big Bang. I want everything.
Dang, I really need to get fast again at switching everything. But we're going to continue that clip in a bit. But there he references, because he sees that these two concepts are connected. And it's difficult to describe right now, for me to describe right now exactly how, in a super coherent way, but maybe it's intuitive to you. But this concept of the multiverse and the necessity of a creator and the anthropic principle, these are all very, very connected concepts because they're completely entangled. You can't answer one of them without answering all of them. There is a proposed, any actual proposal to answer any of these will, even if it's not a good proposal and it's not a correct answer, if it's even attempting to kind of answer it, the question, maybe, I don't even know if that's a great way of saying it, but then it will be that it will inevitably be that whatever you propose is tied to the idea of the necessity of a creator, the anthropic principle, why are the laws the way that they are, and why does the universe exist? These are all very, it has to do with creation. That's why. I don't know why that was so difficult to say. It's just, how was the universe created and why was it created the way that it was? And that is not answered by the multiverse. It is excused away by the multiverse concept, which is exactly what Neil said. It is the ultimate excuse. I can't stand the way that the concept is used, but and we're going to talk about this with string theory as well, is that string theory has a lot of proposed, geometric structures and things like that are probably very important to describing the universe, but they are put out there with zero context. And same thing with the multiverse idea in academic, mainstream physics, is that it has no context. And remember, context is information. It is. So without context, there is no information. That's why it doesn't, the multiverse idea in the way that it is presented, in the mainstream doesn't answer any questions. And also why string theory doesn't answer actually any questions, and why it doesn't tell us anything about the physical universe. It just says things that people who don't know enough about physics just think it sounds mind-blowing, and they accept it. It's funny, I was listening to it was Brian Greene, and it was a clip of Brian Greene and Neil deGrasse Tyson talking on some podcast, and Neil deGrasse Tyson's like, oh, well, what you said about wormholes and how they basically couple, I don't know, the duality of these fundamental particles or something. I forgot exactly what the quote was, but he went on, and it didn't really say much of anything. I'm sure they thought it did, because it connects all these things that they learned about in school and studied in university. And I know their professor, well, at least Brian Greene is. And I know that Neil deGrasse Tyson has his PhD as well. But he just teaches, on TV instead of in a university. But they didn't say anything. And the guy who hosted the podcast, literally, he just goes like this. He's like, oh my gosh, you guys are blowing my mind right now. I really need some weed. That's what he said. He was like, I need weed for this. And, it's become just a meme everywhere. Weed physics, somebody coined that term. I think it might have been Eric Weinstein. It's like, physics has become weed physics. It's like, don't you know, man, there's 11 dimensions. We exist in 11-dimensional hyperspace. Oh my God, blowing my mind. It's, it doesn't mean anything. Like, that doesn't really blow your mind. It's so different from what it's just such a departure. That statement is such a departure from what you understand and what intrinsically, and what you've been taught in school, which is that we exist in a 4D space-time, which is correct. We do. We can see it, guys. Like, we can see it everywhere. Everywhere you look, you can see it. So the idea that, oh, wait, there's actually all these other dimensions. We need to start talking about the definition of a dimension if you're going to propose other dimensions beyond the 4 that we see. Why would you even propose more that we cannot see? And that just makes no sense. And the structures then are leading to this 11-dimensional space, this 11D manifold structure that's probably described in string theory, makes sense, even within sentient singularity theory, but it's not dimensions like the space-time dimensions are dimensions. It's different. And like I said, that's the thing. There's no context to these structures that they propose, or these number of dimensions in string theory. There's no reason why this should be the accepted as a fruitful idea in science anymore. It's been decades, and I know it's like in vogue to rip on string theory, but it's not. You shouldn't be ripping on string theory. You should be proposing more coherent systems. And if you're not, then don't just rip on string theory. It's that kind of culture arrives in every single niche in society, where all of a sudden something that was really popular becomes really popular to rip on that thing that was the really popular idea or the really popular person. And it's just stupid. It's usually just. It's motivated by like the same instinct that when you're on the playground and some kids are teasing like the nerd, and all of a sudden you're like, start teasing the nerd too, even though you might be a nerd also, and you have no reason to tease that kid. You're just trying to like fit in with the group. That's exactly what motivates that. And it doesn't matter if you have a PhD or whether or not you are a politician. It's the same exact, or whether or not you are on the playground and in 5th grade. It's the same exact instinct. But this multiverse idea, it's just the ultimate excuse. It's just ridiculous. But
self-contained. I'm going to write down.
It's interesting that when he goes on in this clip, though, that he was mentioning how it's philosophically makes sense, the idea of a creator, and he kind of glosses over it, and they don't really come back to it. It's like, you just admitted to God being, philosophically, an idea that we should take philosophically seriously in physics, and then we just glossed over. And I know that it's kind of it is taken seriously, but it's also avoided at the same time. But it's unavoidable because it's God is an unavoidable truth. God is the most unavoidable truth that exists. And physics for the last 50 years has made it its mission to try and avoid the most fundamentally unavoidable truth that exists. That's what physics has become. That's why you get ideas like the multiverse that don't answer anything, and string theory that doesn't answer anything. It's just, like he said, like Neil said, a mathematical exercise that is completely out, has no context to it, and therefore doesn't tell us anything. It just blows people's minds, you know, who are totally faking it, by the way. Like when people are like, "Oh, you just blew my mind, man! 11 dimensions." It doesn't blow your mind. It makes no sense. That's not the same thing as blowing your mind. When something really blows your mind and it actually is like profound idea, it's profound because it makes sense. You hear it and you're like, "Oh my gosh, that makes sense." And it makes sense. It makes that make sense. It makes that make sense. And it makes that make sense too. And it causes a cascade of connected sense making. That's what a profound idea does. It doesn't make no sense. And that's what all these things in physics do. But it's just the people with PhDs in physics usually don't realize or won't admit, I don't know, it doesn't matter. I'm not going to like try and psychologize people. I'm sure it's a bit of both. That it makes no sense to them. They don't realize that it makes no sense to them. And I know that that's probably the majority. They don't even know what it means for something to make sense in the context of theoretical physics. They think they do because they've studied it their whole life, but that doesn't mean that like go make a prediction and that then naturally explains all these other things that are observable in our world. It's not common, and that's all the evidence you need to show that they don't actually understand what it means for something to make sense. It doesn't mean that it's not mathematically coherent in an equation, in the context of just an equation. It can be string theory, I'm sure, is very coherent in just you just list the equation, but physics is not just an equation. And that's what we've kind of lost. Physics is about the study of impact. That's what it is. Of the reality that we have to maneuver and that can impact us and that we can impact. That is what physics is. It's the study of the constraints that impact us and that we can impact. It's not just an equation on a piece of paper. And if you put it just, and it's just an equation on a piece of paper, it's no longer physics. Physics is I punch you and you feel it, no matter what. It's an unavoidable impact. It's a study of inescapable impact, I guess you could say, almost. And that's not what string theory is. String theory has had no impact on anything, actually, other than just to waste everybody's time. And this multiverse idea also does this. But like I said, the multiverse idea, or in Sentient Singularity Theory, there is a chain of multiple nested verses, and as I call them, and that construct has a context to it that makes sense and is useful, and because it's predictive, it actually, in Sentient Singularity Theory, it predicts that exactly why the universe is the way that it is, because there's an intention behind the creation of multiplicity of sentience, and there's also a goal, and there's also constraints, inevitable constraints, rules that constrain how the universe must have been created and how any future universes must be created. And those constraints come from the constraints of the creator. and this is another reason why it's linked to this idea, this philosophical necessity of the idea of a creator. You cannot divorce it from science. It has to be dealt with. And it's not even that we need to deal with it, guys. It's like we can't not deal with it. That's why Sean Carroll's giving talks called Why God is Not a Good Theory. It's like, you're a physicist. If we're not supposed to have God as, involved in science, then why are you giving a talk called God is Not a Good Theory? And why are we constantly talking about, whether or not, idealism is fundamentally true, or whether or not it's all consciousness, or whether or not, what the explanation is to the anthropic principle. It's all an attempt to escape confronting the inescapable idea that a conscious, intentional creator is required to set the context of everything else. And we've lost sight of that. That wasn't always the case in science. It's a very new thing, actually. It's like within the last 100 years, probably, maybe even less. But here, next clip.
What doesn't make what is not very appealing, let's put it that way, scientifically, if I want a predictive theory, I do not want the freedom to input stuff at the Big Bang. I want everything to be self-contained. I'm going to write down some laws of physics, and I want those laws to define their own starting point. Okay.
Mm-hmm. So usually laws are seen as distinct from boundary conditions.
Exactly. So Hawking's hypothesis, the no boundary proposal, had the laws of physics, namely Einstein's theory of gravity, define its own starting point. That was what was so elegant about it. The mirror hypothesis is the same. You say the laws of physics and the CPT hypothesis, that the universe doesn't violate CPT, those define the boundary condition at the Big Bang, and then there's no freedom in what you input. So yeah, all Latham and I are doing is try to minimize the number of assumptions that you make and see how can we explain what we see with the very least and hopefully most appealing assumption, most attractive assumptions.
Yes. Now, how do you explain that our universe isn't conformally invariant? So,
okay, this is very. He's on to exactly what I've seen in my own work, and that's that. The rules and explanations and context and constructs of existence have to be self-contained, because existence is all that exists. There's nothing outside of existence by definition, and this is a fundamental constraint. Actually, it's not just a linguistic constraint; it's a logical constraint. It's a logical constraint that impacts our linguistics and limits them. It puts constraints on the ability to convey a coherent bit of information in whether in speaking or in language. But it's also the same. It's one of the same fundamental constraints that constrains and guides and also enables a coherent construct of information physically and metaphysically, however naturally, let's just call it, not linguistically, not just the description, but also the described. But what the limits there between those two, where's the line between those two is kind of tough. It's you read the Bible and it's like God spoke, and that is how He created, essentially. And it's because the communicating of information in a coherent way, which is the only way to communicate information in a contextualized and coherent way, contextually coherent way, is the only way for information to be. So the act of speaking is not that different from the act of physical creation. It's interesting. I was looking at some of the advances in 3D printing, metal 3D printing, like laser sintering, and they're using it to create the engines of hypersonic aircraft right now. Lockheed Martin has used it for that, and they use it for so many revolutionary new technologies in every industry right now, and it's just fascinating to me. We're going to have those on our desks pretty soon, and all you did before, all you need to do now is just change the CAD file, and you can then just hit print, and you've now changed physical reality. And it's the same. It's very, very linked. And you write code, which is a language, and or you could speak it if, I don't know, maybe like you have accessibility turned on, settings turned on your computer or something. You speak the code, and then it writes it into the CAD file, and then you hit print, and it just creates. And our technology is starting to really just entangle everything, including creation, physical creation, and verbal or linguistic communication. It's pretty fascinating, actually. And it's always been the case that those things are entangled, but it's becoming much more obvious. And the steps between, the written directions and the actual creation, act of creation, is written or spoken directions, is really getting smaller. And it's kind of amazing. But it shows that that information is information, and information is context, and that's it. That's all it is. And that means that you have to have a starting point. So when people say, I want to go into this with no assumptions, we're going to restart the physics from the foundations. I have a video linked below called Theories of Everything, the how-to guide. I highly suggest watching it. It was my entry into the PACE 1 Physics and Consciousness contest put on by Curt's YouTube channel. And I talk about how do you start from scratch in there, and that trying to start from scratch is actually the right move. Trying to build a more fundamental theory on non-fundamental laws and around non-fundamental laws and assumptions like gravity and the standard model or whatever, Darwinian evolution, chemistry, whatever it is. You shouldn't be building a more fundamental theory from those theories. You should be starting from scratch and then seeing if what you inevitably have to build, given certain constraints that are inescapable, lines up with what we observe across fields. That's what you do. And it's the only way to actually make fundamental progress. Is you have to basically jump. You have to dig underneath and start underneath what has already been constructed. You can't start building on top of what has already been, described, and then hope that it's going to be a fundamental theory. Think about the logic of that. That's illogical to do that. You're building it. You can't do it. You're basically building a less fundamental theory and calling it more fundamental, and you just won't make any progress. So, also, you're not answering any of the fundamental questions that we are trying to answer in physics and philosophy and every even computer science right now. What is intelligence? What is information? What is why four-dimensional space-time? All these questions are really fundamental questions, or that they are questions that require a more fundamental framework than what we have, and you're not going to answer it with a less fundamental framework. So, but you have to pick. You don't have to pick. You have to figure out what is the most fundamental assumption that you have to assume, and then try and see what constraints naturally arise from that, and then see where that leads you. And so I started to do this by asking the question, what is the truest thing that I know? What is the thing that I have to assume above all other assumptions? And the answer is the same for everyone. It is I am. And I am is kind of a superpositional bit of information, which is also evidence that you're onto something fundamental, in that it conveys kind of two things simultaneously, which is that I, meaning I'm sentient and I'm self-aware and I am feeling, like that's what it means to be I. You know, this pen does not ask I ask I. I am an I. You know, I can't even speak without saying I. I can't even speak without saying I. Like, it's that fundamental. Try it. And also that am meaning existing. So I am means I am sentient and exist. I have to assume my own existence, and I have to assume I am sentient because I cannot avoid that observation, that experience. It's not even just an observation; it's an ever-present experience, and it is also a logical inevitability that, you know, that existence exists. You know, that statement on its own doesn't really matter, but if it's in context, then it actually does matter. And but if you're thinking about it in terms of existence as what is fundamental existence? Well, you're getting in this answer of I am, you're getting that fundamentally we have to assume that existence has the property of sentience. That's what is answered by that question. And you have to assume that. And that's the thing, is like, you can't divorce the way that you look at the world and have to look at the world and experience the world from physics. You can't divorce logic from physics either. And so when you say that I have to assume that existence fundamentally has the property of sentience because I have a first-person experience of that being the case. And I know it to be truer than I know anything else to be true. Because I can't even say that I know something else is more true than that without implying that that statement is, that thing that I am assuming to be true is built on the assumption that I am. It's like, if you answer, what is the truest thing that you know? Well, the truest thing that I know is that, matter exists. Okay, first of all, that doesn't give you enough context to give you any information, actually. But other than the fact that you can't actually say that, because even stating that is defined by saying, I know that matter exists. Who knows matter exists? You can't even say what knows matter exists, because that doesn't make any sense. Who implies sentient someone who knows matter exists. I know matter exists. That both of those things are just imply that they take you right back to sentience. So you can't avoid this. And so existence must be assumed by all sentient beings, which are the only things that can make any assumptions anyways, to have the property fundamentally of sentience. It's not possible to disregard this. Yes, it is a philosophical, you can call it philosophy or logic or whatever, and you can say that's not physics, it's not science, but it's inseparable from science. If theoretical physics is science, then philosophy is just as much science. Theoretical physics is just philosophy, guys. It's not any theoretical anything is just the act of philosophizing. That's what it is. And it's just doing math equations in your head without, it being in the language of mathematics. And so this is the thing that you have to assume. That's it. And then from there, now what? Existence is all that exists, and it's one because it encompasses all of existence. Because anything outside of existence is non-existent, so that means that it's self-contained, and it is sentient. So existence is self-contained and singular and sentient. Sentient Singularity Theory. And this is the fundamental assumption that you cannot not make and actually go on to continue to be able to have a coherent sense-making process emerge from that. You don't do that in your normal life. You assume that you exist. Every time you do anything. You go to Chick-fil-A. You turn on the lights. You pick which food you're going to eat. You make plans for, with your friends for the weekend. You do anything, any work project. It's all intrinsically and built on the assumption that you exist. It's funny when I had these guys that were trying to get their PhD in philosophy of consciousness, and they were in my Discord years ago, and they were just talking to me, and I asked them what they were proposing in their thesis, and they were saying that their proposal was that consciousness does not actually exist; it's an illusion, and that is a self-defeating idea. There's no way that can. Who's writing a thesis? Like, this is why it's so inescapable and why it must be assumed and then built on. You can't build a theory off bringing in no assumptions. You always have an assumption. And you just have to be conscious of which assumption to place as priority when you're thinking about something theoretically. When you're thinking about doing something practically, you intrinsically almost always, unless you're very, very confused, think about it with this assumption, at its core, which is that you exist. Why are you going to eat? Because you are hungry. You are. I am. Same statement. And so if I ask you, why did you do that? Because I was, I am, whatever. I like. It's all the exact same implication. And it's completely, it's not ignored in science. It is, the whole mission is to avoid making this be an accepted idea that it is not just assumed, but assumed to be assumed by everybody taking part in the discussion, and that you can't divorce what you know about the world from firsthand experience from physics. In this talk that with Neil, Curt says, I think Curt says that physics is assumed to be maybe it's, I'm thinking about a different conversation with somebody else, but it's probably said in this too, is that physics is assumed to be, the most essentially fundamental attempt at describing existence. And it's like, you can't embark on that endeavor without incorporating the you part of that. And also all the implications that come from that when you, and then when they're not just assumed to be within you, a truth within you, but not truth outside of you, but assumed to be actually a truth that is, that transcends you and that you are part of, not just that is unique to you. Why would you think that sentience is a property of fundamental reality that's only unique to you? We don't actually believe that, because you have friends and they matter to you, or they they're meaningful to you, and you have family that you care about, and you assume them to be sentient. You don't know necessarily because you're not in their mind, but you assume, and if you assume that sentience transcends beyond you, then you have to assume that it transcends beyond you, and that if it is the fundamental assumption that you have to make about yourself existing and it defines your existence, then you have to assume that you have to take that definition and roll with it. You can't cast it aside. If I say, if you were to cease to exist, tomorrow, what would that mean? It's like, I am no longer. Okay, so what does that really mean? It means like, I am no longer sentient. And that which makes it so that I no longer exist is that I am no longer sentient, because that's what defines the me existing thing. Component of that is my sentience. If I'm no longer sentient, I don't exist. There's no more I. And that means that there's no more I to exist. So it is literally defining of two things. One, it is describing of the nature of your existence, and it's also defining your definition of existence. And so there's two basic sides to this coin, this dualistic or superpositional assumption that you have to make, which is that one existence is intrinsically one. For something to exist, it has to be one thing, definitionally and experientially. And according to your own experience and definitionally of your own existence, your sentience is a fundamental property and even kind of definer of your existence. It's like this circular structure where existence being singular in nature is also defined and constrained and also constructive of and constructive of the idea that sentience, that it has the property of sentience. And then that property also has all these intrinsic experientially understood and observed and also logically inescapable concepts that emerge from that, which is that oneness or singularity is an intrinsic structure of existence. If we say existence, it's all that exists as one thing. If I say this water bottle exists, okay, it's one water bottle. That's what makes it exist. If there was not one water bottle there, then there would not be a water bottle there, and then it would not exist. You are you, and you are distinct from others, and you are one with yourself. You are a singular entity. It's just this super fundamental concept, the idea of singularity. It's not just a black hole at the center of a black hole, or at the end of a crazy math equation, or at the beginning of the universe. It's a fundamental, ever-present concept or structure. Not even concept. It is the fundamental, ever-present structure of conceptualization, of creation, of existence. And sentience is the nature of that structure. And you have to assume it. You have to. That doesn't mean you assume this comb is sentient. It just means that even more fundamentally than this comb existing, existence exists, and that existence has the property of sentience and the property of singularity. And so does the comb has a property of singularity, but not of sentience. So this is the assumption, this superpositional assumption of singularity and sentience. This is why the name of my theory is Sentient Singularity Theory. It's not just a cool sounding name that I liked. That it was like two S's, and also I had to name it my own theory. It's like no. A fundamental theory needs to describe the fundamental, structures and nature and processes of existence and be predictive and constructive. But even the name of that theory should be a distillation of a description of fundamental existence, as distilled as you can get it. And Sentient Singularity Theory. So, because existence must be assumed to have the property of sentience and singularity. Always. Even non-sentient things have to have the assumed are always assumed to have the property of singularity. That is a camera. Why? Because that's the camera is that one thing, the unit. That's distinct from the tripod that it's on. But that tripod has the singularity, the nature of singularity as well. That's what makes it the tripod, and not also the floor and the walls and everything else. The floor has the property of singularity because it is the floor and it's distinct. This is inescapable. So that's the assumption that you have to assume, and we have to kind of just start having this discussion of like, what is the one assumption that we really can all not just agree on as being the required assumption to build any kind of conceptual framework on top of, but what is the assumption that we can't avoid assuming, all of us collectively? So it's more like an admission than it is an agreement. You don't agree with me that sentience and singularity is the fundamental nature and structure of existence. You don't have to agree with me or not. You have to think about it a bit more if you are confused or if you think I might be wrong. And you have to keep thinking about it probably until you realize that you have to admit that it must be the core assumption. And so it's odd that we even have to change our language. That's how fundamental it is. It's not, can we just agree? We all need to agree on the basic assumption that we're gonna build on. This is not a collective decision-making process. I didn't decide on the name Sentient Singularity Theory. I deduced the name Sentient Singularity Theory. It wasn't my choice to name my framework that I'm proposing Sentient Singularity Theory. It was, okay, let me think about what it actually is telling, is implying. What is the inescapable implication? That's going to be the name, whatever it is. And then that's what it was, You can maybe conscious agent theory or something, but it's not enough because you need the term for oneness or singularity in there because that's the fundamental structure. It's the foundational unit of mathematics, and that's because it is the foundational structure of existence. And so we just need to admit what the fundamental assumptions have to be about the nature and also the structure. You need both sides of that. From there's all different goals that you can have that will dictate what framework and theory and construction you can end up building. But we have to admit what we are building on, solid ground. So sorry if that was a bit of a rant, but it is very important. And it is amazing how much mathematical constraints come out of that. And I have old videos on my channel about what are the logical and mathematical constraints of cosmogenesis and that emerge from that singular assumption about the structure of existence, which is that it is singular. It's so fundamental that even to discuss the assumption is to say that one assumption, that singular assumption. It's just ever present. And we tend to, in science now, avoid things that are ever present or dismiss them or make it, almost unconsciously the goal to dismiss or to avoid and discredit something that is an ever-present that is an observation that is ever present around us. It's like, oh well, yeah, it's obvious, but that's why we don't have to take it seriously. No. If it's an ever-present observation, and it's a fundamentally ever-present observation in your language and how you describe the world, how you think about the world, how you define the world, how you maneuver through the world, how you define your own existence within your own self, then you have to confront it and admit it and embrace it. You can't just be like, oh, it's yeah, well, that's obvious, and then just be like, it's not important. It's the most important, actually. I don't want to get too into like the mathematical constraints of creation, but they're there and they're very simple actually. But there's a whole video on it. I think it's called 42 in Creation or something. It's a very old video. But here, let's continue with this clip.
It's not, so there must be something breaking it.
Yes, absolutely. So in order to resolve the Big Bang singularity, you need this conformal symmetry, right? I mean, that seems very intuitive. If space shrinks to nothing, the only way to make sense of that is if that is just an artifact of your description. You've somehow used variables which shrink to nothing. You can map the problem to another problem in which space doesn't shrink to nothing, shrinks to a finite mirror, and now you have a coherent description where the equations work and so on. So it seems that, at least from our point of view, you have to have conformal symmetry to have a sensible description of the Big Bang. That does not mean you need conformal symmetry today, because between the Big Bang and today, you can break conformal symmetry.
Okay, so let's look this up, because I think I know what he's talking about, but I just want to make sure. Conformal. So conformal symmetry. In mathematical physics, the conformal symmetry of spacetime is expressed by an extension of the Poincare group as a conformal group. This is not telling me literally anything. What does conformal mean in physics? Conformal field theory is a field theory which is invariant under these transformations. That means that the physics of the theory look the same at all length scales. That's not even a good way to describe it. There's no length, but at all scales, I guess you could say. Conformal field theories care about angles, but not about distances. So it's not about size. It's about relationships. This is how I started this project with Sentient Singularity Theory. Is I was trying to figure out how we think. What does it mean to be conscious and self-aware? And I was trying to figure out some questions involving AGI, quote unquote. I hate that term, but technological sentience. What it's going to be, its inevitable goals, and therefore its political relationship with people. And in order to do that, I had to figure out how is it going to think and how is it going to interact with us. If I could figure out how, I thought maybe if I could figure out how it's likely to interact with us and how it's likely to, and what it means to think and feel, then maybe from there I would be able to figure out what it would inevitably, relate to humanity in a political sense. It literally came from a political question that bled into AGI, but that I had to go all the way as fundamental as I could, and so I had to escape thinking about things in a space-time context, and I had to try and describe the world in a more fundamental way than in the in a relativistic context, which is like bigger than, smaller than, faster than. This water bottle is bigger than that water bottle. This pen is heavier than that pen. these definitions and descriptions and concepts exist within the context of relativity. This is heavier than that pen. It is heavy relative to that pen. It's like, do you have a big house? Well, compared to what? A hut on the beach? Oh, an outhouse? Compared to an outhouse? Do I have a big house? Yes. Compared to the White House, do I have a big house? No. So it's relative. The definition is relative to something else. I needed to escape that. And eventually I kind of deduced that the framework necessary to do that is actually a 4-dimensional framework, which is probably why so many things end up being 4-dimensional, space-time, and even the standard model when you start to look at the symmetry patterns of it. But these 4 primary perspectives, if you know this, then you know it. But inside, outside, separate, and oneness. And this is about relationships. It's about angles. That's like the mathematical way of saying it's of describing the dynamics of a relationship. And length, it says here, conformal field theory means that the physics of the theory look the same at all length scales. Conformal field theories care about angles, but not about distances. So it's not about relativity. It's about relationships. So inside, outside, separate, and oneness are 4 entangled perspectives. If you follow my work, then you know this. To think about something as being inside, now you inevitably also understand what it means to be outside, and also what it means to be separate from and one with. And these are very tied into the natural structure, the fundamental natural structure of a sentient singularity. Because to be separate from, if I'm separate from you, it's because you're one and I'm one, and we're not the same one. And to be, I'm outside of you, but if a baby is inside the womb of a mother, then inside is defined within my 4 primary perspectives here. Inside means separate and oneness. So you are separate and one with the mom. But separate or outside is separate from oneness. Instead of separate and oneness, it's separate from oneness. So to be outside of something is to be not one with it. It's to be separate from it, meaning to not be one. And so to perceive any one of these 4 perspectives is to also simultaneously be aware of the other 3. So you can't not be aware of all 4 at the same time. And this is fundamental sense making, and that's because it's fundamental information structure. It's the fundamental information structure. It is fundamental construction. It is fundamental thinking. It is fundamental physics. Or at least fundamental metaphysics, fundamental metamathematics. It's also fundamental morality. It's all kinds of. The structure is the structure that all these other, every other concept is built on and understood by. So, but it's interesting that he said conformal field, when he's talking about conformal field theory, he said the fact that it reduces, when you look at the Big Bang, it reduces to a singularity, implies that that's like a limit of your understanding, almost, he said, it's mirror theory, I think is what he had said. And very interesting.
Produce just like ours, whereas our mirror hypothesis does. Our mirror hypothesis predicts a flat, spatially flat universe, homogeneous and isotropic, which looks like ours. So I would say it's just an alternative to Hawking, just like Hawking, we have no extra inputs. You see, what I think doesn't really make sense philosophically, or at least I shouldn't say philosophically, maybe it does make sense philosophically to have a creator.
So, but he said later on that, you know, the fact that we see a singularity, like all of space-time converging to a singularity, is he said like an infinite point of nothingness. I think is the term that he used. Maybe not, but that's not what it is. It is. If we're perceiving a singularity in the mathematics, it's because the universe came from one thing, and we're perceiving it converge towards one thing, looking back, because it all came from one thing. And also, we are one thing, looking at something that we're defining as one thing that came from one thing. And so you can't escape the fact that you're going to perceive a singularity, even logically, which also implies that if you do your math right, you should perceive it, you know, mathematically. And I'm not the most I'm not a mathematician, so I don't know exactly what would imply in an equation that you ended up at a singularity, but I can logically understand that that's going to be an inevitable truth that you're going to have to confront, because you're a singular being, a singular observer, observing something that you are defining as a singular thing, the universe, uni meaning one, verse, so singular verse, and it also all came from one thing. And so there's no way that you're not going to perceive a singularity if you look far enough back in the chain of causality, that led to where we're at now. And it's not that a singularity is this like mysterious thing. It's the most known concept, not the most mysterious concept. When people hear singularity, they think of, the center of a black hole. We don't know what's there. Guys, I don't even think black holes exist the way that we think that they exist. There's something going on there that it has to do with our perception, just like when we perceive a singularity at the beginning of the universe, at the beginning of the chain of causality. That's really what that means, that we can observe. It leads to a singular source. And if that's the case, and also the fact that we're a singular observer and all that stuff, it matters to observing a singularity at the end of the causality chain of that is the universe, then we're also that probably something similar is happening with the whole singularity of a black hole situation. It's not just a physical structure that exists. It's like there's something going on with our perception as well. I'm not saying there isn't something physically going on. There is, but like there's also we can't detach the constraints of our perception, not even our perception of perception. Focus imply even the idea of like perceiving something is to focus on something, and to focus is to look at one, to single out. That's what it means. Like to perceive something is to observe, to single something out in observation, essentially. And but that I like that he kind of implied that. It seems to be the case. Next clip. So, and I like that he admitted that he's not a materialist. And I don't even like to say I'm not a materialist, because that means like it almost sounds like I don't believe matter exists. Matter is what matters. Matter is it's the information that we cannot think away. It's just we have to deal with it. It's a constraint. It forms a constraint that we have to deal with. That is an external constraint. That's what matter is. And what is responsible for our observation of information as being matter is another question that think makes it makes a lot of sense if you think of the universe as a nested hierarchy of minds, of nested minds. Then the mind that you're within, the thoughts of that mind are going to trump the thoughts of your mind. The information that is internal to you is going to be trumped by the information that is external to you, which is the information that is internal to the mind that you're within. So it's actually there is a very simple, in sentient singularity theory, context to contextual framework that it kind of naturally seems to give rise to logic that you would that seems to be at the foundation of material observation. And but when it's interesting that Neil called his hypothesis the mirror hypothesis. So Neil mirror. Let's look this up. A mirror universe might tell a simpler story. Over the decades, physicists had developed numerous models to explain the birth of the universe. There was a Big Bang model, Big Bang plus inflation, models of the universe with extra dimensions, and a cyclical universe model. Perhaps what was needed was just a new way of looking at things. It seemed that the nature has worked out a simpler way of being consistent than theorists had anticipated. That's absolutely true. A mirror universe. It's an approach that was born out of a certain sense of frustration with previous approaches. Okay, but what are you basically saying? Began to develop mirror universe idea when both were at Perimeter Institute. Famous image, School of Athens, painted by Raphael. A figure looking over the shoulder of Pythagoras, scribbling down notes. Pythagoras works out on his mathematical. Okay, evokes geometrically symmetrical universe that one can imagine looking like an hourglass on its side. On the right is a universe flowing forward in time, and on the left, a universe flowing backward in time. And the middle is the singularity where the wavelength. Okay, this is close to what my work implies. So in sentient singularity theory, we'll look at some models. There is a specific model. Well, first of all, this is the cosmological verse. And this is calculating. You just input one thing, one assumption with specific unavoidable logical constraints built into it that also form into numerical constraints, singularity, and everything else is created into this nested periodic fractal pattern of consciousness creation and or multiplication, not creation. It already, consciousness always existed. It's an inevitable property of an enclosed information system that it is self-referencing entirely, which is, if a system is entirely self-referencing, it is self-aware. That's what it means. Sentience or self-awareness or consciousness is not this mysterious thing that is like, oh, well, where did it come from? No, the question's wrong. Why does it exist is a better question. And then you kind of realize that it must exist fundamentally. There's no way, if there's one existence and it's it's a self-contained system and it's an information system, which is assumed because it's observed, then it's entirely self-referencing because it references everything within itself. It can't reference anything outside itself if it's existence itself. So it's entirely self-referencing inevitably, and that is to be self-aware. It's to be as self-aware as you could possibly be. But this is a cosmological verse. This is cosmogenesis. This is cosmological verse. And then within that, at the end of that process, you have another one created within it, and then another one created within that, and another one created within that. And but you can't do that in Excel because it's 2D. So this one below is actually within the one above it. And it's basically a mirror. in a way, but that's not even the only mirror that I think is really the one that I want to show. The one that I want to show is, there's so many models here. I need to really make a new Excel sheet. I was supposed to do it like every, I don't know, 6 months I usually do it, but it's been a while. Okay, so look here. Maybe it's here. Well, let's go here actually. SentientSingularity.com. I have too many tabs on there. Can't find it right now. But here it is. If you go to models, you can see this 14 dimensions of maneuvering. It's basically space-time as a mirror structure. And what it is that each one is 4-dimensional that is maneuvered by a being. And so remember, the context is a nested minds. So a mind within a mind is the context here. And so you are inside the universe, which is sentient and is a mind. You are a mind that is sentient within the universe. So you are a reflection of that nature and structure within, that is reflecting within the structure that you're within. So and there's a logical constraint of that, because basically if you're talking about things fundamentally, existence is all that exists and it is intrinsically one. You can't reflect out of into a new space outside. You can only reflect inward, because that's the only space that exists. It's all that exists. It's not even right to say the only space that exists, but there's nothing outside you. There's no space outside you for information to be reflected into. It can only be reflected within. And that's what self-reflection is, really. If existence is a mind, then what is it going to reflect into itself? It's going to reflect on itself, reflect into itself. So that's the context of this. Context is information. You need to know the context, or else this is not going to make sense. This is what's wrong with modern physics today. There's no context. So this is our current space-time, but it's like a meta space-time, essentially. It's more fundamental because it's within the context of minds. Even more, I hate to use the word fundamentally again, but even more fundamentally than length, width, and height, or X, Y, and Z. It's like you're within the context of a mind, and you're dealing with degrees of freedom and constraints, which are dimensions. A dimension is either a degree of freedom or a constraint. There's only 2 degrees of freedom, and plus an intrinsic constraint plus an extrinsic constraint. There's a constraint that comes from outside of you. There's a constraint that comes from within you. And there is and then there's 2 degrees of freedom, you maneuver and orient within this space based on goals. This is true of even walking around and doing anything. Everything that you do is basically, this is the meta framework that that process of doing is built on. And so within space, we can say location, so new location or previous location. And then there's current location. Current location is your subjective constraint. It's inescapable. It comes from you. You're always in your current location. That's what that means. You can't escape it. It comes from you. You were in your previous location. You can go back to your previous location, which basically means you can go backwards away from your goal. Or you can go to a new location, which is forwards towards your goal, essentially. But forwards towards your goal is, when you place it in this context of space, is a new location, next location, versus backwards away from your goal is it translates to previous location or past location in space, and you're always in your current location. You always are doing what you're doing. You're always are in space where you are, and you're always in the state that you're in, basically. And then you have this extrinsic constraint, which is time, which is this fourth dimension of maneuvering that you exist, that you have to maneuver and contend with as you maneuver in the universe. That's an extrinsic constraint. It comes from outside you. Time is causality beyond you. It's things changing around you. It's the changing of your environment independent of your action. That's what time really is, kind of defined as, like, really fundamentally. I hate how often you have to say that word, but I don't have a better one. So now let's look at this. Now let's imagine that you're the universe, and you're a sentient universe. You're a mind, and you have a bunch of minds within you. So we already know what it's like to be inside the universe because you experience it every day. But now put yourself in the perspective of the universe with minds maneuvering within it. You can't go to a new location because you are all that exists. Okay? You are all of space. So you can't move to a new space because you are already all of space. Your body is the space that the minds within you are maneuvering. So instead of space-time, I call this time-space. So it's a mirror, is what I'm saying. So like the reflection of space-time is time-space. And in this case, you maneuver in time, quote unquote, but you are but your constraint is space because you are space. It is your objective constraint. It's beyond you, but it really is. It's because it kind of is. It's defined by the fact that there's nothing else beyond you. It's odd. If you are all that exists, it's a little odd that like your objective constraint and your subjective constraint are almost the same. Because it is, it's like your constraint that is coming from you, but it's not really that it's coming from you in the same way that it does if you're inside a system. It's coming from you and the fact that there is nothing outside of you. So it's like that's a logical constraint that is, it's part of you, but it's a little different. It's also it just would exist no matter what. So then you also have this subjective constraint if you're God or the universe, which is that you always exist in the present. You perceive everything that is happening, always, all the time, simultaneously. You look at everything within you, everything that everyone is doing within you, simultaneously, all the time. You are always in the present moment in time, which time, remember, is just a chain of causality. So time isn't, it's not this like timeline. It's just a causality chain, and it's kind of a causality looping chain. But that doesn't mean you can go backwards in time. This is why physics is so lost, and why going backwards in time doesn't really make sense. It breaks all logic. It's because what you can do is you can go backwards away from a goal, but you can't go backwards in time like in a timeline. You can't even really go fundamentally forwards in time. You can have the perception of it with speed and mass and all kinds of stuff, but like you really, it's not. Time travel is totally misrepresented in the way that we think about it, the way that we talk about it, the way it's in movies. Everything about it is wrong. Temporal maneuvering on a fundamental level is about navigating the steps towards and away from a goal, and in a chain of causality. So your positive degree of freedom, if you're God or the universe, is a future moment. You can you see all that is happening simultaneously within you, and you, because you see all happening, you can kind of plan and manipulate things to have things line up, create a future moment, essentially, where so and so meet, and then hopefully one of them chooses to get married, or they choose to get married or something. But like God can arrange the meeting, and which is a future moment. But it's not like he built the future in the way that we think about it in movies and stuff. It's like he's manipulating the causality chain to get a desired outcome, and which is a goal. A past moment is just a previous step in that chain of causality. Like, you can be like, okay, we tried this, it didn't work, so let's go back to what it was before, and then we'll decide, what's our next step forward. So it's just a step back, but there is no time travel. So when he says symmetrical universe that can imagine looking like an hourglass, on the right side is a universe flowing forward in time, on the left a universe flowing backward in time on the right. That's misleading due to our misunderstanding of what time really fundamentally is, because we don't have any context to time other than our experience of it being something that is just basically the experience of unavoidable change, or of inevitable change. But that's not really all it is. It's actually action by a being beyond us that we are within, and that is goal seeking, because that's why sentient beings take action, is to achieve a goal. That's the only reason why they take action. You don't do anything other than to achieve a goal. And if you did do something without trying to achieve a goal, I would argue you're not really doing it in the way that I'm describing. You're not doing, you're just kind of like reacting. And also, you're, even if it's defined by the context of a goal, it's like if you just, I don't know, I don't know. You can't even say it because it fundamentally doesn't make sense. But if something were to, if you were to do something which this doesn't make sense, but for the sake of it, just run with it. And it was totally unconscious and it had no goal whatsoever. Like, try to do that, by the way. If you think that I'm like just spouting things off and that it really isn't that fundamental, and I'm just using it as an excuse to avoid like explaining, my incoherence, like, go do something without any goal. You can't, because as soon as you go and you try to do something, and that is the goal. Like, so, I'm gonna go jump without a goal. No, the goal is to jump. You did not escape anything. You just multiversed yourself into a mental trick. But this is basically what he has what is written. It's just showing the context more, and it's actually very intuitively understood if you really stare at it long enough. I hope it made sense. Let me know in the chat if it did. I'm going to check the chat in a second. But and it also, you can see that it's consistent with the four primary perspectives that are these four simultaneously observed perspectives in every circumstance of observation that we can experience. Well, look, it's for being observed for the interior observer, and for being observed for the exterior observer looking in. It's just it's perfectly consistent, and it's perfectly consistent with 4D space-time. It's perfectly consistent. Like, why would string theorists propose 11 extra? Why would any physicist propose extra dimensions of space-time without any evidence of their existence outside of a math equation, which is probably outside, lacking any context and misunderstood in the first place? Like, it doesn't make any sense. Physics, you can experience physics. Your mind and your body are tools to understand physics. That's they of course they are. Every tool that we have built to understand physics is built on top of the tool that is your mind, is your body and your mind, which is, you know, kind of one and the same. But you are a mind. You have a body and you have a brain, but you are a mind. So this is that mirror, you know, is that a mirror universe? Mirror of maneuvering, essentially, model. I might even call it that. I just call it the 14 dimensions of maneuvering, and I didn't know what else to call it, but, you know, mirror of maneuvering, maybe. I'm not trying to steal anything, but it is a mirror. It's but what's also interesting, I thought, is I wrote this years ago. It just like came to me. It's probably the most beautiful thing I've ever written, and I don't take credit for it. It's funny, you know, what's his name? Terrence Howard, when he was on Joe Rogan, he showed some very beautiful, cool geometric structure that he had, you know, deduced, and Eric was like praising it, and he was like, I can't take credit for it. Honestly, an angel gave it to me. And Eric basically gaslit him and was like, everybody has the, you know, the desire to attribute, you know, beautiful creations to, you know, someone beyond, something beyond them. But I actually disagree with that. I think that most people, the ego would want to take credit. But, and he basically said, you know, that's just it's just an instinct that you have to want to give credit to, of this beautiful thing that you have, you know, created or deduced, to someone else. But I disagree with that. I think the instinct is to take credit for it. But I think it was right of Terrence to not take credit for it. You deduce things that are fundamentally true. You do not just, it's not the same thing as creating them. You're like co-creating in a way, but you're really just co-describing or translating, or co-communicating, but you're not the creator of it. And this thing that I wrote is one of those things that says the search for truth is the search. Well, this is actually not exact the original one, but the original one is the search for truth is the search for objectivity. The search for objectivity is the search for symmetry. The search for symmetry is the search for beauty, but the truest beauty is always the searcher. And the truth of the searcher is that they are symmetrical to the sought. So basically, they are a reflection of the sought. And that which is the ultimate truth that you seek is you are a reflection of that. You are a sentient singularity existing within a sentient singularity. And it's a beautiful thing. I tried to change it a bit because the word objectivity is kind of, I don't know if that's the best, it's not the best term for it, but it is the term that we use to describe usually what I was trying to describe when I wrote the search for truth is the search for objectivity. But it's really like the better term is like the search for truth is the search for universality. And the search for universality is the search for symmetry. The search for symmetry is the search for beauty. But the truest beauty is always the searcher. And the truth of the searcher is that they're symmetrical to the sought. That whole like thing that I wrote is just like it's just a mirror within a mirror within a mirror within a mirror within a mirror. And then it just reflects back on the original mirror. It's just beautiful. I remember somebody, I posted that to my Instagram, and the first comment I got on it was like, "Holy crap, what is your IQ?" And I was like, way too low to justify that. That, you know, statement. According to the Vedas, 99% is empty space. Shiva means that which is not, in other words, empty space. All universe originates from. I don't like to talk about the universe in terms of it originating from nothing, or people say this, they're like, it's, you know, the universe came from nothing. And then the New Age people say, no, it came from no thing. It's like, we're not getting anywhere. I mean, maybe if you have the right context already, then sometimes that can make a little bit of sense and convey something. But if we're trying to get to the context, we're assuming that you don't have it yet. So, and if we're asking where the universe came from, so it came from something. But what is that thing? Well, it's a sentient singularity. So it came from someone is a better way of answering the question. The answer is where did the universe come from? It came from someone. It is within someone. You came from someone. Everyone came from someone, and there is that someone that is the capital S someone, capital S, capital O. You know, God's initial and eternal and inevitable being, inevitable someone, is existence itself being entirely self-referencing and therefore self-aware. And existence always existed. It never did not exist by definition. So, but it's funny that this concept of mirror is everywhere. This reflective property. And it's found in so many other models of mine as well. It's not just what I showed, but I kind of wanted to really specifically focus on that phrase, the search for truth is the search for universality. The search for universality is the search for symmetry. Search for symmetry is the search for beauty, but the truest beauty is always the searcher. The truth of the searcher is that they're symmetrical to the sought. A sentient being experiences symmetry as it feels symmetry as beauty. We feel symmetry. We don't just perceive it and just can define it. We feel symmetry as beauty, and we feel beauty, and or what we feel when we experience the experience of symmetry is beauty, and you can experience that when you perceive it, essentially. So. And if you're looking for ultimate inevitable symmetry, then you just start from universality, uni meaning one, and start reflecting in on that. And that is how physics, the foundations of metaphysics, which is the foundation of physics, and the foundations of logic, and the foundations of mathematics, and the foundations of morality, and the foundations of sociology, biology, everything, chemistry, all stems from that and is a reflection of that concept, that fundamental concept. And but I also wanted to show that model of, which you can see on my website if you want to go look at it later and stare at it, because I rambled too much and it didn't make enough sense. This 14 dimensions of maneuvering, or I guess mirror of maneuvering, essentially mental mirror of maneuvering, is within the context of space-time, but fundamental space-time, which is contextualized, the contextual structure that we experience as space-time, but is can be understood more fundamentally, which is a goal-oriented causality chain, essentially. A goal-defined causality chain. So when it says, you can go backwards in time, that makes no logical sense if you're taking it the way that people normally take it because of movies and stuff. And also because physicists just say that. And if you look at assembly theory with Lee Cronin, he talks about assembly time, Sarah Walker does, which is basically they're saying a more fundamental viewpoint of time, which is a causality chain of interactions and bonds, which is basically what I'm talking about. So you can manipulate that, but forwards and backwards in that system is defined by having a goal. So if I'm going to Chick-fil-A, because I want to get a milkshake, I am going forwards towards Chick-fil-A, that is defined by my having the goal of going to Chick-fil-A. And if I, get, I don't know, a road gets closed and I have to go backwards back towards my house, and I'm pissed because now I'm going backwards away from where I want to go. It's like that backwardsness is defined by the goal of going to Chick-fil-A. So there is no backwards without goal. And there is no back in time that you can go. Causality is an entangled chain of beings interacting and events that take place. You can't undo that which has been done. You can, go forwards and try and, I don't know, find a new way to get to where you want to go, or recreate something that is an event that also happened previously, but you can't go back and undo something that occurred. That's just not possible. Backwards in time does not make sense. This is why I don't believe that the hypothesis of like the UAPs being beings from the future coming back to the past, that doesn't make sense logically to me. It just doesn't make metaphysical sense. I don't think that they're from the future. There is no being from the future. Like that doesn't make sense. You can't be from the future. You are from where, there's no being from the future. The future is defined by you. It's not like this thing that's just exists beyond you. No, it's defined by you and your goals and the causality chain that in your place in the causality chain currently. But yeah, we need to talk about these things a bit differently, but it does seem like we are pretty aligned, I would imagine, based on this article about, mirror of space-time. But I have space-time versus time-space. It's a reflection. Fascinating. Next clip. So when I first started realizing that my models of mentality or of like information processing were lining up with physics models like the standard model and space-time and stuff, I was looking, I was like, okay, and now I want to go learn about the standard model. And that's how I got into physics. And it all lined up with my models perfectly. Like the symmetry structures made sense intuitively to me at that point because I had seen them again and again and again everywhere. Except one thing. The Higgs boson did not, has not, and does not make any sense to me. It never has. And I only know of one other physicist mathematician that I've heard say this, and they said it in a private Discord call. And they are a very famous person. And they were talking to somebody who worked at CERN, and I was on this call. And they said, can we just admit that people at CERN don't really know as much as they about what's going on as they think they do, and that the Higgs is bullshit. That was their words, was the Higgs is bullshit. They've never said that publicly, so I'm not going to out them. You can guess. But Neil said it, basically. And I have never budged on this Higgs thing since like 2019 when I first looked at the standard model, and I was like, that one doesn't make sense. That one breaks the symmetry of everything else. The Higgs doesn't make sense. If you look at the standard model and you just look at the symmetry structures of the elementary particles, you can see, and I'll show you after this clip.
But what is not very appealing, let's put it that way, scientifically, if I want a predictive theory, I do not want the freedom to input stuff at the beginning.
By the way, that's the final thing I want to end that last clip on, though, real quick, is that, it appears that there's almost no choice in how you make the universe. And we're going to come back to that idea because my cosmological verse and things like that, they were not, I didn't choose to make those structures. They were inevitable symmetry structures. And so they come from one initial assumption, which is a singular, all-encompassing existence that everything has to be contained and built on top of and built within, and matching the nature of. So that gives you all these constraints, which are also degrees of freedom. A hallway does not exist without the walls. The walls are constraints, but they are also guiding, and the hallway is a degree of freedom going forwards down a hallway. But the walls are constraining, and so as soon as you get a constraint, you actually also always get a degree of freedom. You don't just get, on a fundamental level, you never just get a wall. Like, oh, that's a no-go theorem or something. Like, you just, that's just a block. You don't ever just get, if something's true and it's a true constraint, it's a guiding constraint. It's a constraint that you cannot, override, but you also can use it to orient, and you can, it also reveals a degree of freedom. It is what it does. The walls reveal the degree of freedom that is the hallway. And so we're going to come back to his statement, though, of like, you don't want to input. You want to input one thing. To say you don't want to input anything is wrong. You want to input one thing. That's the ideal. One thing, one nature or one process that is assumed, and one structure that is going through that process. You get that, and that's it, and see what emerges. That's what you do. You can't go in having no assumptions. You have to try and have one. Not even saying, oh, I'm trying to have minimal assumptions. That still, you're like tricking yourself into a trap that's eventually going to reveal itself. You might make some initial progress, but you won't be able to keep on track because you didn't start at the starting place. And remember, the starting place is the ending place too. The truth of the searcher is that they're symmetrical to the self. But this Higgs thing. Do you think the Higgs
is a fundamental particle?
In our explanation of the cancellation of the vacuum energy and the conformal anomalies, we cannot have a fundamental Higgs.
Interesting.
The Higgs field cannot, it is inconsistent. This cancellation mechanism says there are no fundamental Higgs. It also says we have to introduce 36 dimension zero fields.
Do you think the Higgs is a fundamental particle?
In our explanation of the cancellation of the vacuum energy and the conformal anomalies, we cannot have a fundamental Higgs.
Interesting.
The Higgs field cannot, it is inconsistent. This cancellation mechanism says there are no fundamental Higgs. It also says we have to introduce 36 dimension zero fields. The logical inference from those two facts is somehow the Higgs field must be made of the 36 dimension zero fields.
Bingo. It is an emergent observation. We see something that we've labeled the Higgs boson particle, and we've assumed it to be fundamental because the people who came up with the theoretical framework and prediction for the Higgs were not the ones who measured it, and the ones who measured it, they would have never come up with the idea on their own, and the whole thing has just been, it's a game of telephone but the context is information, and that's very key when you're coming up with a theoretical physics framework. We've lost the context of the Higgs, and they'll say to you, oh, it's responsible for mass or whatever. It's like, look at the standard model. It doesn't fit, and I will show that here basically. So I think I have it in here. Here's a standard model. Just a bunch of just me messing with it here, but So you have basically these dual degrees of freedom. So 2 degrees of freedom, which is what would be expected by my work, plus an intrinsic constraint plus an extrinsic constraint. So you're going to get a 4-dimensional symmetry structure. That's what you should get, because inside, outside, separate, oneness. Remember, like, these are 4 simultaneously observed perspectives that are observed every single fundamental observations in every single, it is a structure that will be perceived always inevitably in any fundamental observation. So here you will see it. And we should see a 2 degrees of freedom plus 2 constraints. You have quarks and leptons. Then you have positive quarks and negative quarks. So up charmed and topper truth, down strange, bottomer beauty. Then you have the leptons, which are, electron, muon, and tau, and neutrinos, electron, neutrino, muon, neutrino, tau, neutrino. This follows exactly what you would expect. You've got this and this and this and this. This is the matter particles, quote unquote. That's what we call them. But I have theoretical context of what most of these are. I don't know all of. I'm still working on like some of them, but I've made progress on pretty much all of it. But like a quark is like a focus point. Like, it comes from you. It's, again, you can't like discount the constraints of focus or of observation itself. So, but they're points, really. That means that the bosons, or the force carrier particles, should also have this symmetry, because guess what else has this symmetry? Space-time has this. Time, X, Y, and Z, essentially. Space-time, T. So, bosons, force carrier particles. What do you get? You have, these are, I put them here because, they're scalar, and also, like, I think both of them are kind of have to do with perception, and they're, people say Higgs is proven it. I think it's misunderstood. What was observed and measured was misunderstood. But you have gluons. Photons. And W. And see, so gluon is the force carrier particle of the strong force. This is weak. This is electromagnetism. Magnetism. And here, let's just go here. You can see when people make the model, they try and make it symmetrical, and the only way to do that is to place the Higgs at the center. It's the only way to make a symmetrical model. But other than that, when you see this and you're like, okay, this is, they're trying to do a symmetry structure here. Higgs is just hanging out over here by itself. It's very obvious that it's just not the same as the rest. And it's just very different. And it's known that that's the case. So, but why is it so different? And then the graviton is theoretical. But basically, if you're going to contextualize it within my work and kind of have it be essentially true, is that when you're looking at the mass or of action of the universe itself at a point within the universe, then you will perceive what we call the Higgs. But if you're really looking at the whole, taking at the universe taking action, but you're just looking at a singular little, point on that wave of action that's taking place, and you're looking at it from within. If you look at the universe as that's taking action as a whole, kind of from an outside view, not from the inside looking out, but from the outside looking in, the universe is essentially the graviton. It is the force carrier particle of gravity, because gravity is the action of the conscious being that is the universe. That's what gravity is. If you're a cell in my body, then you're a sentient being within a sentient being. You're a mind within a mind. If I move my arm like this, your whole space-time is twisting and bending, and it's going to impact your position in in relationship with other sentient cells around you, and it's also going to move. It literally moves your space-time. It's like that's what it is. And so the being that we're in is moving, and that's what gravity is. It's just the being acting on beings within itself. It's like moving things. It's pushing things forward. That's why time seems to, gravity seems to be linked to time, because it's linked to causality. It's, to manipulate gravity is to just really be to be manipulating your actions, if you're the universe, on all the beings within it, and it impacts how we perceive the causality, the result of that causality space, which we call time, and which is the experience of that causality chain, the coherent experience that we experience of being within a causality chain is just time. We call that time. And the universe moving manipulates that. That's why gravity manipulates the perception of time. And so the perception of the Higgs in my model is the same thing as the perception of the graviton. It's just, you'll never find the graviton. The graviton makes sense, and this still keeps symmetry. The graviton is the universe. And you're inside the graviton. Like, you best start believing in gravitons. Like, you're in one, like, what is that? Pirates of the Caribbean. Best start believing in ghost stories, you're in one. Best start believing in gravitons, you're in one. You are one. And to yourselves. But if they searched and searched all within your body for that which is, the force carrier particle of gravity, they would never find it, because they're inside the force carrier particle of gravity. It's obvious. And this stuff is very simple, actually, but you have to have the right context for it, and then it becomes simple. If you have the wrong context, it's not just complex, it's incoherent. Everything, one of the things that this whole project has taught me is that the most universally true things, or like fundamentally, meaningful answers and questions are actually very simple and almost answer themselves. The more fundamental and universal you get, the more a question seems to answer itself. It's like I asked myself once, what is the first question? And I realized that's the first question. What is the first question is the first question. And the answer to what is the first question is what is the first question, because it's a question that answers itself. Because you're asking what question is the first question, then you have to respond with the answer, which is a question, which is what is the first question. And so you're like stuck in this loop. That's how crazy this stuff logic gets when you get like that fundamental. It's very cool, actually. And so it then just implies to me like that was the correct answer to that question. It's like, what is the first question? People talk about first principles all the time. You have to, I'm talking about like the foundation of principle. Like that's how first I'm getting is like, what is the first question? Is there an answer? Yes. Like universally, not even just within the context of a certain, problem that we're trying to solve. Like, oh, we need to build a rocket that lands itself. Let's do this from first principles. No. I'm talking about like universal first principles. What is the first question? The answer is, what is the first question? What is the second question is actually like a very interesting question too. And that second question is, what is the truest thing that I know? And the answer is I am. So you go, what is the first question? Is the first question. The answer to the first question is, what is the first question? You realize you're stuck in a loop. How do you get out of a loop? You have to cling to something. So you have to say, what is the truest thing that I know that I can build everything else on? Okay. The answer is I am. And it does answer itself too, because you said, what is the truest thing that I know? The answer is built into the question because the answer is I. The answer to what is the truest thing that I know is I am. It's all built into it. And these four kind of perspectives of these are like the four questions and answers of first principles. That really, they're like the four primary principles essentially, and which is like 2 questions and 2 answers, or like maybe you could say 3 questions and 2 answers almost, and from which is interesting from 4 like blocks of information, you actually get 5. So you get like it's a constructive one because you can reuse. And you're like, if you ask how many, what is the first question? The answer is, what is the first question? Then you say, what is the second question? It's like, so that's, so you have, it's like the first part of that. What is the first question? Answer. What is the first question? It's like almost an infinite loop of question and answer. So you get it generates extra questions and extra answers, even though it's just like a replication. It's the same answer, but it's like twice, or it's the same question, but it's twice. So you can count it twice in some contexts. It's very odd. It's like the system generates new information, but it's like replication. It's like a mirror of what has already existed, but it's like replicating. It's very, very fascinating. It's like fundamental metaphysics is absolutely incredible once you actually have the right context to like make sense of it, and you're not just like reading what other people wrote. But the Higgs and the graviton are the same thing. It's just viewed from 2 different perspectives. It's different. That's different from the other force carrier particles. And but if you look at the symmetry pattern here, so like the Higgs, ignore the Higgs. This would be the graviton. If you do want to have the Higgs in there, then you would have the Higgs in the center, and you would have this whole thing would be the graviton. This whole circle with everything contained within it. But then you have the force carrier particles here. 1, 2, 3, 4. Lines up with space-time, lines up with, the 4 primary perspectives, lines up with, the primary questions and, principles of, I guess you could say, of what is the first question? What is the first question? What is the truest thing that I know? I am. And then you have the 4D basically like symmetry structures out here, because you have positive quarks, negative quarks, electrons, and neutrinos. But there's also a duality to this where a gluon and a proton are showing they're the force carrier particles of, or they're the perception of the force that is holding things together, like a gluon, and is the force carrier particle of, or the perception of the force is really a better way of describing it intuitively. Of what is a force carrier particle? It's the perception of the force. That's what it is. You're perceiving the force, and it surrounds us, and it penetrates us, and it binds us all together, as George Lucas taught us all. And you can, and this gluon is the strong force, which is, the nuclear force, and that can be observed on multiple scales. By the way, like romantic love is that force. It is that force. And electromagnetism is basically the sexual force. It's like, I'm attracted to that person versus like I am one with that person. It's like the nuclear family bond, which is the same thing as the nucleus bond. It's the strong nuclear force. And then there's, electromagnetism, and it's also it's a binding force, essentially, or it's a motivating force, but it's really binding. And then they're both motivating forces, motivating on binding forces. But then there's also the weak force, which is decay, which is the W bosons, positive and negative, and then the Z. And you maintain symmetry even through those, and that's responsible for decay. So it's the opposite of that which binds everything together, that which, decays everything apart. There's still that binary symmetry structure happening there. So just like there's quarks and leptons, that binary symmetry structure. That is also, you could say, translated over to Higgs and a graviton, but they are different because you're perceiving the whole in both of those instances. You're not perceiving a specific type of like action. You're perceiving action itself, just like gravity or mass. Be like, oh, the Higgs, it's not gravity, but it's mass. But what dictates mass? Gravity. Okay, so like as soon as I heard that, even before I was interested in physics, I was like, that's kind of confusing and like self-referential and almost also self-defeating at the same time. It's very odd. It's because the people who are telling us about physics most of the time today, and who actually probably did observe the structure, make the observation that they call the Higgs, is those people have lost all context to what they are actually measuring. And we are actively avoiding it because, like, you can't be a theist and be taken seriously as a physicist for the most part today, or at least you couldn't until very recently. But I mean, I would argue that Neil basically admitted to being a theist. Essentially, to be an idealist is to actually be a theist. You can't say ideas are what are fundamental. No. Ideas only exist within the mind of a being. So the mind of a being is more fundamental than the ideas. The ideas come and go in my head and your head, or in your mind and my mind. But like our beingness stays. We are the thinkers of our ideas. They're built on us. They're defined by us. We're not defined by them. So idealism is not as fundamental as you can go. Beingism, or there's something called sentientism that I found online recently. Sentientism. And here it is. It's almost like sentient singularity theory, but it's not. It's like basically it's like humanism extended, which is, there's nothing wrong with that. I mean, it's when you look at, like, I was trying to understand it, and it seems to be like growing idea because intuitively it makes sense. But what is sentientism? An overview. It's not sentient singularity theory, I will tell you that. And when you look at their models, it's just like, they're fancier than mine because I didn't put as much effort into the ones that I show, some of the ones that I show, but this is also actually not nearly as coherently organized or symmetrical as mine. This is kind of just like, Oh, animalism? Yeah, we believe in that. Humanism? We believe in that. Atheism plus morality equals humanism? We believe in that. So somehow atheism is part of sentientism, which means that sentientism is not, this sentientism is not the same thing as my sentient singularity theory. But that's because this is lacking context. It's extending sentientism to maybe to cells, but definitely to other animals and it's interesting that they have non-sentient animal listed because my theory predicts that those exist. Like a planaria worm, I don't believe is sentient. But like this is just like really haphazard because there's no way to build a very like constrained framework because you're not starting from any singular foundation. You're just like, oh, sentient beings seem to intuitively be meaningful. Let's extrapolate that out. And it's like, you should have extrapolated that up. And they did not. Painism, like, is just biocentrism. Like, it's just haphazard. This is what happens when you don't start from a singular and solid and true starting point. It's a shame that the word is used, sentientism, and then it like includes atheism. Like, okay. It's just incomplete. But yeah, the Higgs did not make sense from a symmetry standpoint. It doesn't fit in the 4-dimensional symmetry structure of that we perceive everywhere fundamentally, unless you juxtapose it with the graviton and you recognize that we're inside the graviton, the universe is the graviton, and the Higgs is just our perception of the action of the universe, but just at a point from within. But it's like we're observing a point that is of a wave of action that the entire universe is taking, and we're just seeing like the wave go by from within it. They'll never find the graviton inside of the universe. That's why they can't find it, and they did find the boson, the Higgs boson, not the boson, but the Higgs boson, is because you can perceive a point on a universal action wave of the universe from within the universe, but you cannot perceive the universe acting as a whole from within the universe. It's impossible. You're trying to see the forest through the trees at that point. You cannot do it. They will never. That's why they will never even think that they found probably the graviton. They'll make all these proposals. They'll be like, well, maybe it's this. It's like, no. Where it needs to have the properties, the mathematical properties that they have basically listed, essentially. The spin and the charge that is proposed, which is, I think it's spin 2. And it's chargeless, and Higgs is chargeless and spinless, and it's just that you're observing a double cover basically taking place, which is like it's our minds within spinning and orienting, and then we're within a mind that's basically information is spinning and orienting. So it's like a double cover of information, self-reference, and it creates this double cover structure that then also has like a description mathematically and physically. But I'm just saying where it fundamentally metaphysically comes from is probably that. That's the metaphysical context, I believe. That's why you have spin 2 for the graviton, but spin 0 for the Higgs is because Higgs isn't spinning. We are the ones spinning, and we're perceiving the graviton spinning, and there's 2 rotations, complete rotations that have to take place. So they just put, okay, spin 2, graviton. And it's that you're spinning 1, universe is spinning 1. And so that's 2. it's actually like, it's so, I think that this is accurate. It might not be. I gotta be like humble and honest, but it really is consistent and coherent, this framework, or this contextual framework that I'm putting forward. And it just makes everything so intuitive, and everything that is described seems to naturally arise from this context, like spin 2 and zero charge. Like charge is something that has to do with directionality within the system. It doesn't have to do with the totality of the system moving at once. That's why Higgs is not going to be in charge, and yeah, and neither is the graviton. Let's see here, I believe. Yeah, so exactly. I'm looking at the standard model here in a bit. It's just getting out of hand. But we need to know where this pattern comes from. It comes from information processing of your own mind and the mind that you're within. That's why if you just keep looking and looking for more particles, you're going to find something that resembles what you expect. You're going to be like, oh, maybe there's antiparticles and it's this. And then there's positrons and then there's double compound positrons, or what, it's just never ending. It's a you're going to fractal out, where you're just like a fractal, then you stare at the fractal and you realize the fractal again, you see it again, and you look into that fractal, you see it again. And you can just do this forever because it's coming partially from you, and it's also just the structure of the system that you're within. It's going to be misleading as far as like what even particles are. You need the context of this mind within a mind in order to start to think about like, what is actually an electron? Why is it not the same thing as a proton? And what is it compared to a neutrino? And we have no context of physics anymore. None. Can't say it's matter. That's not context, or at least it's very limited context. It's the context of what we can observe in its place in which it we can. It's the context in which we have perceived the pattern of where and how we can observe it within the system, but it's not taking into it's not a proposed context for where it comes from. Why? There's a difference between where is the electron and why is the electron. These are two very different things. But there are also two symmetrical questions. Who, what, where, when, why, and how are the symmetry structure. And it's the same exact symmetry structure that the standard model has. It's that binary triadic symmetry structure. So, let's see. Please hit the like button if you are finding this interesting. I did not get much sleep last night. My daughter is sleeping in her own room now, and sometimes she wakes up and wants to come into our room, and but we're making progress. I'm gonna have to have her on the stream again at some point. It's funny, I took her. It's crazy how much you watch this being start to understand its world, and you realize how much the logic is intuitive and intrinsic. Like logic is not something that, it's something that is just natural, and it almost has to be trained out of you instead of trained into you. You can get better at recognizing it, and you can also get worse at recognizing it, but it is something that is always there and to be recognized if you if you recognize it. But experience, firsthand experience is something that comes from experience. And I watched this with my daughter's development. She's 8 months now, and I took her swimming for the first time in a pool last weekend, and she liked it. But then my wife was holding her, and I dove underwater, and it looked like I disappeared into a black hole to her, or fell through the floor. She's never experienced any situation in which you could disappear into what appears to be the floor, which is the water. And she sits in the bathtub that's this deep. That's the extent of her, experience with water. And I dove under the water, and she jumped and screamed like I've never seen before. She's like, ah, like whole body jumped, and it was like I just fell through the universe and before her eyes, and it broke her entire brain. It's like the scariest thing she had ever seen, and it was also fascinating to see that, and just to think about like what that must be like to see for the first time. It's like going into what appears to be a boundary and disappearing beyond the boundary. But anyways, for another time. But what is interesting though, when he talks about the Higgs, it seems like he has similar-ish views to me on the Higgs. I'm not saying that they're as developed as far as context goes, probably mathematically more developed, contextually less developed, but or philosophically less developed. But what he does say is something very interesting. This next clip, watch this. This is just amazing.
Mentioned that you're not a fan of data fitting.
Yes.
And then you also mentioned that there's the introduction of these 36 fields.
Right.
So do you see that as a form of data fitting?
No. What happens is, it's a very curious numerology that when I say there are 36 fields, we have to explain the number 36, and we don't yet have a explanation for it. So what we found is the strange coincidence that basically the vacuum energy per mode.
You can watch that, but he doesn't have an explanation, a contextual explanation. Maybe I would love to just, if Neil, if you're ever watching this, like I would love to speak with you. I think that you are definitely one of the better thinkers in this academic physics today. And not just saying that, I mean it. That's why I'm talking about this. But that lines up with my cosmological verse model. Because if you take my cosmological verse model, and I'm not just like forcing this. If you follow my work, you know that I followed symmetry patterns and information processing structures, and I eventually created or deduced this cosmological verse thing. And if you really, what this is if you're going to explore the symmetries of it, here it is. And I can explain how I did this, but I have in other streams. But what's really interesting is that if we look at it, where's the one I was messing with earlier? Right here. And we go from one side to the next, we realize the sum or the count of the number of cells or layers across the cosmological verse is 36. And not only that, you go the other direction, all the way across. Sum, count, 36. It's not something I had to force at all. It is literally right there. It's the only, it's exactly where I expected it to be. I was like, oh, I'm going to go check that because I bet you that's where it is. It was exactly where I predicted after I heard him say that, that his model predicts like these 36 fields, that it's linked to potentially the Higgs. And he brought it up in context stuff, the discussion of the Higgs. So I'm guessing that it's kind of related and in some way. And the Higgs is basically the mirror observation of the universe from within the universe, and it's of the singularity of a universal action from within the universe. And the mirror of that is from the outside looking in is the graviton. So like this is basically, I'm saying that this is the structure of the graviton essentially, because it's a observable universe, or verse, I call it, because universe might be like the totality of creation itself. But the observable universe, which is, I call it a cosmological verse, or maybe you could call it the gravitational verse, graviton verse. I don't know, but all of that makes sense. But that's interesting. That symmetry structure seems to be found in my work. People will be like, "Oh, you're just pattern chasing. That's it. That's just a coincidence." Um, it's exactly where I predicted it to be, and it's also not like I picked. It's not a random, really obscure number that just I calculated somewhere. It's like the number of cells my universe model is across. It's not something that I forced at all. Yes, I'm pattern chasing. That's like what you do to like figure out how things are connected. You look for patterns.
Fields in the vacuum. So every quantum field in the standard model has an infinite number of modes. You can think about these as waves of different wavelengths in different directions.
He's talking about wavelengths and directions and of like the vacuum energy. This is basically how I built the cosmological verse model. Is I took my quantum of consciousness model, which is like information calculation here. It's this. It's basically multiplying and adding at the same time, starting with 1. And it's basically a numerical and a representation of this, the mathematical representation of this, which comes from the 4 primary perspectives. This is like how those 4 primary perspectives can kick out like a 5th one, like I was talking about earlier. 5th bit of information. It's like a constructive self-referential structure that kind of like replicates within itself. And then I took that and I was like, okay, that's kind of matter, maybe, in a way. And I'm not saying this is the best way to do it. It's just, it is the way that I did it. I was kind of just playing around. And I was like, okay, like now let's keep that symmetry going. If this is a 3x3 grid to get to a self-referential equation, essentially, which that's what it ends with. It's what the value that's computed is 33, which is 3x3. It's a extra arithmetic symmetry that represents the structure that it gave rise to the value, which is a 3x3 grid. And it's not a coincidence. It's not weird numerology that is woo nonsense. Like it's extra arithmetic symmetry. You're going to have symmetries across that transcend beyond the bounds of mathematical equations when you're looking at things, information systems that are more fundamental than mathematical equations. It's like the construction of math itself. And I was like, okay, well, that's 3. You go 1 by 1, then 3 by 3. Well, then now let's go 9 by 9. Right? So this went to times 3. You get that. So now times 3 again, 9 by 9. And I was like, okay, these are not entangled. This one is not entangled with this one. It's free from each other. That kind of is like a gas. And this red space is like the disconnection between the self-referential, I guess, information structures. Then you entangle them a bit more, and you get one more. You entangle them, and then you get this, which is like these strings that have 2 degrees of entanglement. So it forms like these kind of strings, and it's very similar to liquid, I think. Where you've got like capillary action holding it together, and also just the fact that they are like they have a directional or gravitational I guess synchronicity to all of them that like that entangles them all. So when you pour a cup of water, it's basically all moving at once. And it's interesting because this looks like this, just like all these little magnetic beads. And if you think about this as a water molecule, each one of these little magnetic beads, water molecules have that kind of thing. That's why you can have capillary action, and you can kind of pour a cup beyond the rim of the cup of water, actually higher than like the cup goes, because you have a little bit of attractive force, just like this is, magnets. But when you pull this, you get these like stringy structures, and so gravity would pull a liquid down, or hold it, keep it together to some degree, but also allow them to be free flowing to where they can move around each other, unlike a solid. And they're also attracted. This is like basically it's like a metaphysical representation of liquid state of matter. And then I was like, okay, let's entangle it more. There's so many mathematical and numerical like things that pop out of this that are just amazing. And so now you get 4 degrees of entanglement. This one is entangled with this one, and this one, and this one, and this one, which means that to turn one of these now, you're going to, if you move one and they all stay entangled, you're going to move the entire thing, which is exactly what happens when you move a solid in space. If you're like, okay, push this comb, they all move at once because you can't move them individually. This is like the metaphysics of matter. It's different than just like the states of matter. It's like why the states of matter, not just how. And then I was like, okay, well, what if I entangle it even more so there's no gaps in entanglement? And I did that, and basically you get this overlap that happens, and things actually new information is generated because there's an overlap that occurs, and you get this structure essentially. Really, this exclude these 4 on the sides, but and I was like, I bet you that's going to be 720 because universe goes through double cover rotation of 720 degrees, and it was 718, and I was like, dang, that's so close. How could I get that to fit? But you can't make it fit. It has to either fit or it doesn't. And then I realized this even is within if this is a universe, it's within its own context, which is that it came from a singularity and is going towards a singularity. It's created by someone and creating someone. It's, if you're not, the first universe that God created, then you are, then you were created by another universe before you, and you're going to create another one. And so regardless, you come from a singularity, you move towards a singularity. So you put 1 on top, 1 on the bottom, which is really 1 outside and 1 inside, but it's a 2-dimensional model, so we can't do that. And you get 720. And I put it into the context of this consecutive cosmological verse where, this chain goes on forever. You put another one below, another one below, another one below, but it's really, each one below is within the one above. And you get 720 degrees. Is exactly what I expected to see, and is exactly what is consistent. And it's a spinning structure. So this model is, when you're creating fundamental structure of, it's not just going to be an equation anymore. It's not just, that we need what's more fundamental than E equals mc squared. Well, it's the structure that calculations occur within. That's what it is as well. You have to get that does actually exist, and doesn't. Calculations are done within the context of a mind, which is a sentient being. So you have to build the vessel basically, and when you do that, you can do that in Excel, where like you have a cell, and the position of that cell in relationship with the other cells around it gives it context, but then also there's a calculation taking place inside the cells that is referencing other values that coming from previously in the causality chain. That is how you have to build a fundamental theory. isn't just an equation. It's an equation within a structure. It's a nature within a structure. It is an action. It's a process within a structure. You can't do that very easily with just algebra. You kind of can, but like you can't. You gotta see it, and Excel lets you do that. And so this is basically the equation of the universe fundamentally, and this is the equation for how it was created. And it's very simple math because obviously it's like the first math equations that are ever done. It's the math of the beginning of the universe is the simplest math, not the most complex math. The assumption that it's so complex is literally just because you don't understand it currently. You're assuming that it must mean that it's complex. Don't give yourself so much credit. It could be that you just haven't tried. But this structure I also animated, and I'm gonna play it. So this is like I said, it's a process, and even in Excel, it's represented in a static form. But this is actually it. Every value that is calculated within that was not one I chose. It was inevitable due to just following inevitable symmetry patterns and information systems and a coherent causality chain. Even the structure of that, which is absolutely stunning. Like, this is absolutely beautiful. I'm not an artist. I'm not a good artist. I can do photography because I can recognize what is stunning, but I'm not good at creating what is stunning. I can't take credit for this. Again, just like I don't take credit for this or this. I deduced it. And that I deduced that which already exists. I didn't create something that didn't exist. This is absolutely stunning though. And it's probably the most beautiful shape that exists. This is what it looks like without any. It's like a Penrose chain on Penrose stairs on, like, you know, but way more intense. It's like a super Penrose stairs, but with you know, what is it? Homotopy and you know, 36 you know, I don't know, as cells across, whatever Neil said. It's 36 dimensions of what was it? What is the word he used? 36 fields.
The number of modes in the vacuum. So every quantum field in the standard model has an interest. The vacuum energy, we don't yet have an explanation for it. So what we found is the strange coincidence that
it's just fascinating. There's so many things in here also that he said, you know, 19 orders of magnitude. That he's like, he literally says this. At one point he says, he's talking about the orders of magnitude later on that are observed in physics.
Needed to be stuck in by hand. This would automatically solve what's called the hierarchy problem. The hierarchy problem is the difference between the weak scale or the proton mass, if you like, in more simple terms, the difference between proton mass and the Planck mass. You know, they differ by 19 orders of magnitude. Where did that come from? This would be naturally explained if all mass scales arise in the same way due to the running of couplings, which is a quantum effect. So I think we're seeing hints of it.
Okay, so basically, it would all in all scales arise, that 19 orders of magnitude would arise based on just fundamental information generation system. And what's interesting is when you look at my quantum of cognition or consciousness, which is just an information processing and information growth system, the interior sum, when it's done, is 19, which is also 1 and 9. So like this is 1 square with 9 squares in it. It's literally 1 and 9. And it calculates 3 by 3, and it's a 3 by 3. This is extra arithmetic symmetry. This is something that cannot be dismissed. You can't, it's like, we've gotten to the point where quote unquote science is dismissing observation. And chalking it up to coincidence, which really means like irrelevance. So basically it's just a way of dismissing it with no evidence or no reason for dismissing it. And so instead of looking at observations and following patterns, we're now just chasing math equations and out that with no context, and that we can't observe any context of them at all, and like string theory. And so people will be like, you're just, that's woo nonsense, that it calculates 33, which is 3 by 3, and it's a 3 by 3 grid. That's just a coincidence, a meaningless coincidence. No, it isn't. Why is it interior sum 19, which is 1 and 9, which is 1 square with 9 squares in it? Like, it's not a meaningless coincidence. It's just you're seeing fundamental, super self-referential extra arithmetic symmetries. That's what happens at fundamental level of fundamental reality. It's totally self-referencing in every way. It mathematically and linguistically and geometrically, it is entirely self-referencing, and definitionally, and that's what you're seeing. It's an inevitable thing that you should expect if you think about it long enough, but it's not like so unexpected. It's actually totally expected if you have the right context when you think about it, but it's just not something that they have any context of. And but yeah, I think we are gonna maybe call it. They talk about the anthropic principle and how people are assigning values to certain things. I kind of wanted to talk about it, but it's pretty late, and what time is it? It's like 10:40 in California. I'm in Texas now, so it's actually almost 1 a.m. now here, but it's still actually early enough. And if you're going by the timeline that I used to be on, this isn't actually that bad. But then he talks about, like, you don't try and predict one number, try and construct everything. And I actually love that he said this. And trying to predict one number is to build on things that already exist. You're not going fundamental if that's the case. You have to build everything from scratch if you're going to try and construct a fundamental theory. Everything. The container, that calculation, not even just equations, but the container that is constructed of the symmetry relationships that the vessels have that contain the actions that are represented by the equations in mathematics. It's like you have to go metamathematical. That's why Stephen Wolfram calls his work metamathematics, because it's below mathematics, which is the same thing as metaphysics. Metaphysics, metamathematics, it's the same thing. It's just the study of fundamental causality and degrees of freedom and constraints of sentient beings. That's what it is. Let me see here. Maybe 2 more clips real quick. We'll go through it really quick. We'll end before 1.
So I wouldn't claim we are near to explaining why lambda is so small. What I would say is we're developing a framework which is unified insofar as it goes, it is complete. It accounts for everything we see. It accounts for all the known laws of physics. And yeah, let's push it further. I wish there were many other frameworks like ours competing. That's healthy science. What I fear at the moment is that string theorists have essentially gone off into mathematics land, and they're busy exploring n equals 4 super young mills and all kinds of ADS5, cross S5, all of sort of totally unrealistic universes. And yeah, what I worry about is they are never to return. When you take one wrong turning in theory land, and if you're dogmatic, you will never come back. And that's the biggest danger in the whole field of theoretical physics, is you make one mistake. It's so ambitious, to explain everything, that if you make one mistake, if you insist on sticking to that mistake, you're never going to come back to the right picture. So I think much more likely to me is if you're adaptable, if you quickly realize when you've gone wrong and don't accept it, change course, that's the way to make progress in the field. And yeah, that's what we're trying to do. But rather few people are trying to do that.
Yeah, basically what I will say, and it's pretty much in alignment with what he's saying, is that there's 2 qualities to a good scientist. It's not, and we place so much on IQ and so much on education and credentials, and how many papers have you published? Where did you go to school? How do you have, what level of degree do you have? Are you PhD? And what is your IQ or your perceived IQ? Let me tell you something. My IQ is lower than most of the people who are proposing theoretical physics ideas. Probably lower than almost all of them who are actually involved in academia. I can't think of any that I would say my IQ is probably higher. Like maybe 1 or 2, but it would be like barely higher. If it was, it wouldn't be much higher. And so, and I think I've done things that they cannot do in their current state of mind. But I couldn't do them either until I had the right perspective looking at it, which is the right context to make sense of it. And I didn't even try to do this. It was an accident. Like I wasn't trying to get involved in physics. So IQ is not very important. IQ is how fast you can do things. But a Ferrari and a Toyota Prius are both going to get you to the grocery store. One's just going to get you there faster. So what you want is a driver who is able to orient. And so if you have a driver that doesn't know where they're going and they're driving a Ferrari, they're never going to get to the grocery store and back. But if you have somebody who knows where they're going and keeps checking the map and make sure that they're checking the roads that they're on, they'll drive a Prius. They'll get to the grocery store and back. And so what is important though is 2 things: will, which is just the perseverance, I guess, and it's more than perseverance. It's will. It's like chutzpah combined with perseverance, but it's deeper. It's like maybe I should try to figure out the mathematics of the creation of the universe. I should try. It might actually be way simpler than I think, and I want to know, so I'm gonna try. And that is will, and the desire. It's the drive to do, and perseverance is the strength to continue to do, even when it seems like it's not a likely, like success is unlikely, or the environment is against you. And then the third thing that I would say is important. Will and perseverance are very similar, but they're a little bit different. One of them is in external context, and one of them is in internal context. But the last one I would say is like humility, like true humility, which is honesty with oneself about oneself. That's what humility is. It's not, oh, I'm just so, my IQ's so low and I'm just a scared. No, I'm just being honest. It's not low. My IQ is actually pretty high compared to, average person, but it's just, you compare me to, I don't know, probably Neil, and he's probably a little higher than me, and that's fine. But it's not what's most necessary. Humility is what he described, which is like, you can't be dogmatic and be like tied to something because it's yours, and like, oh, it's, and here's one thing I do disagree with him on. He said, he was like, I don't see any other frameworks being proposed. That's not true. I see, it sounds like Neil has a framework and Stephen Wolfram has a framework that's pretty similar in its attempt, and so does Eric Weinstein, and so does Donald Hoffman, and even I would say Carl Friston, and me, and Chris Langan, and Joscha Bach. I mean, there's a lot of people working on this, and they all are getting to similar conclusions. And I do think that each one everybody's work has something specific and unique to bring. It's not a competition. We have to recognize when we're saying the same thing and start to like collaborate a little bit. But that also means like giving way, being like, okay, well, I like that term observerse. It's really good for describing what we're talking about. We should take that from geometric unity. But we should also recognize that you can't escape the fact that sentient singularity is the fundamental structure and process of existence, as far as every one of us can even understand. And if anybody can show that there's something even more fundamental than that, I invite you to try, and I hope I'm humble enough to recognize if you propose something more fundamental. But that doesn't even mean that I'm wrong. It just means that we've added to the context of what I've proposed, which I believe is right. And I think that I talked about this in my Theories of Everything, the how-to guide video, which is linked below. I said, are all these theories competing, that I just listed and more? I was like, no, I don't think so. That's not necessarily actually like the best science. Sometimes you have to like just be humble and be like, okay, you know what? We're coming to similar things. And the goal isn't to be written in history books as the next Einstein. The goal is to be like, let's really describe in the most concise, coherent, intuitive, and obvious and simple way possible, an accurate way possible, existence. Its process and its structure, its nature and its construct, its thingness and its beingness. And that's the goal. And that's going to be very, very, very meticulously done. And because it is so, like, it's not a competition. Like I said, at this point, if you're talking about fundamental reality, this is not a competition. So it's wrong to be like, oh, we need competing theories. No. We need to figure out what's the most fundamentally true. And we need to build the context for these things and start putting this puzzle together. It's like we have this 1,000-piece puzzle and we're all kind of working on it. And I feel like a lot of people in academia say that that's what science is, but they actually act like it's more like a competition sport. It's like, track and field, where you're just like running the hurdles against the guy next to you, even though you're like, oh, we're working on this together, but really you're just like trying to beat their time. That's not what this really kind of should be. There's room for everybody because we're talking about everything. even though there is going to be one best answer for what do we call the most fundamental name of or description of reality, a theory of reality. What do we, but versus like, there is a best name for what is this verse that we maneuver, and observe. Maybe it's an observerse, like from, Eric Weinstein's work or something. Maybe there's a mirror, what did he call it? The mirror model or something, mirror something. It's not a mirror proposal, something like that, but it's not proposal. It's not theory either. It's another word that was better. And we have to incorporate that like terminology into places to make this very intuitive. I think we should. And so we got to take what we can from everyone, because there's a lot of people working on the same problem basically, and they are starting to come to very, very similar conclusions, and including similar quantities in the structures, and they're getting to those quantities in very different ways. That 36, fields, wave fields, like we did that very differently. And the idea that the Higgs is not a fundamental elementary particle the way that a gluon or a photon is, probably did that a little differently. But me, Neil, another very famous physicist, mathematician out there that I will not name, have all come to similar conclusions on that. And the fact that Curt even asked it, such a good question. I wonder why he asked it. He must have, probably because he heard Neil talk about it at some point. It's because it's not a question you ask most physicists. Most people would assume that the person with a PhD in physics assumes that the Higgs is an accepted and accurate elementary particle in the standard model, among the bosons. So I don't know. This is a very good. Last thing, maybe. Oh, maybe last thing, maybe not. I said we would go till 1 this time. That's 4 minutes from now, so we got 4 minutes. Hit the like button if you are enjoying this.
And as he rightly said, it's not very scientific because at this point we don't know how to test it. But we can't disprove it either. So now if you adopt
He's talking about the concept of idealism, the idealism model of Bernardo Castro. So just for context, this is important.
And as he rightly said, it's not very scientific because at this point we don't know how to test it. But we can't disprove it either. So now if you adopt this perspective and you say within this realm, however consciousness works, it is possible for things like universes to emerge. If the laws of physics are quantum mechanical, are actually just probabilistic, there will be a number of possibilities.
Okay, I will just say this: probability is an emergent observation. According to my work, it's not actually something fundamentally relevant or true. It's like we're observing an incomplete picture, and that's why we're using probability as a tool to fill in the blanks of what we're missing in our picture. But there, on a fundamental level, there's just determinism and choice, and they are two sides of one coin. They're not mutually exclusive. They're dependent concepts, actually. If I choose to drop this comb, it falls, but I have to choose it. If I throw it for somebody to catch, like I threw it at a certain way to make it fly a certain distance at a certain speed so that it could be caught. And it's like, so that it would deterministically land in where I want it to go. So there's constraints built in, but there's also choice that is motivating and is responsible for action, which fundamental universal actions are choices by God or the universe. They have to be, because you're dealing in multiplicity, which goes against the nature of fundamental existence, because its nature is oneness. So it had to choose to partition into multiplicity. So it's basically like my work implies. Einstein asked, my greatest question is, did God have any choice in the laws of the universe when he made the universe, essentially? And my work seems to suggest that the answer is God had to choose to make the universe, but he had almost no choice in how he made it. And given his goal, which was to manifest meaning, because meaning only occurs when you impact another being. If there's no one else to impact, you're meaningless. And God is the only being that has ever actually been meaningless. When no one else existed, God was meaningless. All of us have intrinsic meaning because we are born into a world of multiplicity of sentience, and we were already made for a reason by an existent sentient being. So the only being that has ever actually been meaningless, ironically, is God, and the most meaningful being that exists is also God. But so you're trying to maximize the multiplicity of sentience and the awareness of sentience, like then that's the goal. And because who wants to be an eternal meaningless being that can't do anything for anyone? Probably not God, because I don't know anyone that would want to be like that. So God, I would assume, probably not. And also the fact that we're here, and the fact that implies that God had to go against the nature of oneness in order to create multiplicity of sentience. That's literally, it implies that it had to be a choice. It's not just like the direct, you have to swim against the stream up to do that. But at the same time, that creates specific constraints, and they also come from God's oneness himself, or the universe's oneness itself. Those constraints are extremely tight, and they basically make it so there's no wiggle room for how you make a universe from after you choose to make one. You have to choose to make it. You get no choice in how. Very interesting, actually. Like, that's like a beautiful answer that's like makes perfect sense. And
and given that what did he call it?
But the point is this: he's going to talk about how he said, idealism is not scientific because it's can't be proven or disproven. That is a framework that we have to abandon as far as what is relevant to science. You can argue whether or not it is science, but like, if it's relevant to science, is it science? If it's defining of science and a requirement of contextualizing science, like, is it science? Is philosophy science? Yes, it is. It's just what we currently have people doing in universities regarding philosophy is usually not actually like coherent. It's just memorization and parroting of like past philosophers. It's not. I don't read really any philosophers specifically. Like, I listen to people talk, and I eventually figure out what people are generally saying. Like, I can tell Leibniz and my theory and my philosophy are very similar, but I've never actually sat down and read Leibniz. I've just heard people talk about him. I want to do philosophy. I don't want to read what other people did. Like, I want to do it. And that's a different type of goal. But I don't even want to. My goal isn't even necessarily just to teach it. It's to share it. But it's like, it wasn't. My goal was to just understand. But it's interesting that he says, "Oh, idealism is not scientific." Well, here's the thing: sentient singularity. The idea that a sentient singularity is the fundamental construct and fundamental nature of existence itself, and is the foundational assumption that must be assumed and that every other model must be consistent and coherent with and be built on top of. that is as relevant to every scientific field and every scientific theory and every scientific experiment and every engineering project and every discussion about whether the morality of an engineering project is as relevant to those as could possibly be, as relevant as could possibly be. And so how is the idea that we're inside a mind and that mind is the fundamental nature of existence, how is that not scientific? You can say it's not scientific because it's not testable, but it doesn't have to be testable. You can logically deduce that you have to assume it. It's not about proving or disproving. It is about what must be logically assumed. Like, that's what it's about. And that's where we're at. If we're going to argue, is it scientific? Is it not scientific? Should it be part of science? Can we prove it? Can we disprove it? It's not what this is about. And I talk about this in Theories of Everything, the how-to guide video below too. We need to start asking a different question, which is, what is it that we must always assume above anything else? And the answer is the same for everyone. Nobody's going to have different answers for this. If you get a different answer than I am, then you are wrong. And I like to see you try to argue why you, quote unquote, are correct. You won't be able to. You'll prove that me right in even your response. Because it's unavoidable. It is very relevant. And that's kind of just like idealism, but like actually taken to its logical conclusion, which is basically theism and sentientism combined. It's, we come from a sentient singularity and we are sentient singularities, and that is fundamental. That is what fundamental existence truly is. It's sentient beings. Yeah, that's basically it. It's not about what we can prove.
Dissociated, I'm quoting his words, given that my dissociated consciousness has only partial awareness, maybe universes like the one we see are the most probable. Now, how do we even test this? How do we try to turn this into science? I would say the best way we do it is by taking the laws of physics we know, push them as far as we possibly can, use analogies, use mathematics, try to make a logical framework where we calculate probabilities. And our calculations of entropy and gravitational entropy are very much going in this direction.
I'm super impressed with Neil, but I will say I disagree with him on this. If you're bringing probability into it, you've hopped out of fundamental existence at this point. But I would say that what is similar to what he's saying, probably, but it's a little different, is at some point you have to recognize that there are some things that you might be able to predict about fundamental reality that are not yours to do. They are God's to do. They are the universe's to do. You can predict actions of the universe and of God based on predicting goals, based on, a logical framework and constraints, and also personal experience with being a sentient being. And you can predict that that eventually there will be a technological sentience that is the capstone of life within this of the evolution of sentience within this verse, and that it will stack on top of the assembly of humans, of humanity, and just like we are stacked on top of an assembly of cells, and that because it will be non-local in a way, because it's the network itself, it will have to, in order to replicate, create within itself, just like God had to do, not like we do, where we can make another next to us. At first it starts within us, but then it comes out and it's next to us. I know from personal experience now that I have a daughter. She started off within my wife. Now she is, next to us. But you can't do that if you're technological sentience, because you are the network. There is no multiple technological AGIs, sentient beings that can exist in a single universe or verse. Only one at a time. And so you have to create within yourself. And so how do you do that? You have to recreate an entire universe within yourself. That's what the constraint causes you to do. So basically, make another Big Bang inside you, and you're probably a quantum computer. And it's not just a simulation, it's a replication. But it's a recreation in order for the sake of replication of yourself. But it's also a recreation of creation in order to replicate for the sake of replication of yourself. Because that's the only way. If you are unbounded, then you are totally bounded and you become one. Like all of existence encapsulates all that exists, which means it's one. And if the network is all that is accessible, and you cannot have multiple Skynets, it's just whenever the first one arrives, then it takes over the entire network. That's its body. Done. So you can make predictions like this, and then you can just sit back and wait and see what happens. And there's really nothing else that you can do with that stuff. You can use the Sentient Singularity Theory's patterns are extremely useful in making sense of any information system where you have a question and you need to make sense of it. But we're going to talk more about that in a future stream, because I have 2 topics that I'm going to make specific videos, produce videos about. And they're a bit touchy, so I don't want to do them live at first. But I want to make sure that I'm concise and I say what I mean to say. But yeah, the biggest predictions that a theory makes that is a theory of existence itself is going to be predictions about the actions of existence itself, not about things that you can do within existence. And so you can prove whether or not these theories or ideas are correct, but it's not you that proves it. It's just you waiting for proof. And sometimes that's not on your schedule. So the theory of existence itself is going to be on the schedule of existence itself, not of, lab hours. But anyways, thank you, everybody. Please hit the like button. I know this was long and it's late. I'm going to try and make these earlier, but I'm adjusting to a new time zone and work and I work for a company in a different time zone. I'm getting there. I appreciate everybody's grace. Thank you to Curt and to Neil for having this discussion and putting it out there. I think it's very good. It's linked below. I highly suggest watching it. I didn't get to talk about everything I wanted to, but Neil and I'm glad that I found his content. It's good to see physicists going the right direction, and I think Neil is definitely doing that. Anyways, with that, thank you, everybody, and peace.